This video is the module 1 of my AI for Leaders program, which is designed specifically for business leaders, managers, architects, product owners, or decision makers who are responsible for designing, approving, or scaling an AI-based system. So this is what you can expect in this whole video. We'll begin with first program outline, the intent and target audience. So after finishing this whole program, what you can expect. We'll also look at the program philosophy, the learning approach, the whiteboarding, some of the example use cases, everything that we are going to look at or you're going to learn from this. Then we'll go into high level outcome, program outcome on what you'll be able to achieve once you complete this. Then we are going to look at the whole learning path thinking like enterprise AI architectures, advanced prompt or RAG engineer, or retrieval augmented generation. We'll look at validation, evaluation metrics, fine-tuning, RAG, end-to-end including right all the way till deployment on the cloud or on-premise infrastructure for AI-based systems. Once you've understood the actual big journey from this particular video, which is going to be roughly around 2.5 hours, is introduction to generative AI. That's the whole point. We'll begin with AI as a conceptual level and differences between descriptive, diagnostic, predictive, and generative AI. These are the 4 different AI-based systems that we'll be discussing about. Then we'll go with what exactly a model means, which is a combination of data and the algorithm that we use. Algorithms ultimately comes out as a part of this model. So we'll look at that. We'll understand the difference between predictive versus generative, and within predictive or discriminative AI, classification, regression, forecasting, recommended system, and then now with generative AI, what that actually means. Once we have done, we'll look at the generative AI model families, including large language models, and then image generation model, which we are going to look at GAN and diffusion model. We'll also briefly touch base with multimodal, which is nothing but text, image, video, and different models as well. So that's going to learn. Once that's done, we are going to look at the transformer model, which is quite famous and why they matter. And within that, we'll also look at RNNs and LSTM, which is the background in order to understand the transformer model. We'll also look at encoders, decoders, and encoder-decoder architecture, because that will dictate what kind of a model you're going to pick based on the business use cases or on that you're deploying for your companies as well. We'll also look at embeddings and their roles in order for these AI-based or generative AI-based systems. We'll also look at fine-tuning versus generation models and briefly touch base in this particular video about RAG. We'll also look at validations, metrics, and governance, and then model alignment, ethics, and biasness. We'll briefly again touch base with AI agent autonomous, but these topics we're going to cover in subsequent future videos as well. And then we'll do final about towards a mixture of expertise, model, what that mean and how this being come into picture. And then we'll touch base with cloud deployment strategy, but we'll go again deeper in the future videos as well. Finally, we'll close with expectations on what you'll be able to, what you've achieved on this particular entire video. And then, as I said, I'm going to do towards and a final takeaway from this and saying, which will, you should be able to get a clarity on AI, which is not a black box on, and we'll be gaining a structured chronological understanding of what these AI systems are. And if you're new to this channel, my name is Atul. I have to close to 2.5 decades of IT experience working with some of the big clients here in UK, Europe, US, and all across the globe as well. And I've gone from earning less than $100 a month in India to coming here in the UK, working 425, 500, 700,000. Now I charge in excess of £1,000 a day. Now, whatever I've learned over the last 25 years, now I teach by putting in my 3-step framework, going from being not confident to super confident in AI, machine learning, generative AI, to no interviews to having multiple interviews call, and from no job offer to multiple job offers. And this is what I've helped thousands of individuals like Steve, Debashish, SJ, Devesh, and Shrija, and hundreds of thousands like you. Now with that, let's go and look at the video. Now in the description section or comment section, I'm going to add some supporting document, and any questions that come from the video, leave them under comment section, and I'll put in my some additional material or whatever these slides we are using will be able to give you in the description section. So don't forget to check in the description section. And if you have any questions, leave them in the comment section of the video, and I'll make sure that I'll reply to you. With that, let's look at the video.
So the overall course is intended for business leaders, decision makers, architects, project managers, product managers, anyone who is going to architect an end-to-end GenAI application. So they have some decision making in control. That's the fair assumption. Okay, if You are one of the developers of a much larger team and you don't have much say in the architecture, in the framework choice, in the cloud choice, in the strategy, in costing, then probably this is going to at least frame your mind. So you may not be able to leverage it immediately, but at least you will have an upper edge. You can at least contribute to some of those decision making as and when you get chance in your organization. So that's the high level idea.
One tip
So
I'll
these are
give
the
in.
main.
Sorry again. I'm going to interrupt sometime in the middle because I'm going to give you my feedback. How I came very quickly and learned pick up these things was that even if you're not with that background, if you've not done that, maybe go not to find fault in the project or something, but ask and say, hey, by the way, have you considered this? Have you done this
Yeah.
in a manner to help and support and guide? Now, very,
Yeah.
very important. Your intentions are very, very clear and very, very important. If you go to any C-suite leader, if you go to any architect who's an enterprise architect, if you go to any team lead, if you're not part, if you're part of the team or if you're team lead, you need to know how to lead them, how to give them. Don't try to be confronting. Try to be in supportive and say, "Hey, oh, by the way, oh, I was doing this thing. I was discussing with someone, and like this, they were suggesting this. Oh, can we? How about this? Can we suggest this?" Those are very, very important points. A second thing is, let's suppose you're not part of the team, you're an enterprise architect, but they are not including you in an AI related project. They think you are in a cloud or they think you are an on-premise, you think something else. Maybe go and talk to them in a nice, friendly manner and say, hey, we were just, I was going through some things and have you considered like that? So that way it will be useful for you if you're not part, because they will bring you, because finding that kind of a skill set is very, very rare. It's not a lot of guys know. Number one, so it's very, they will bring you on board and they will love to hear from you and start incorporating. That's why you'll enter. Point number one. Point number two is when we talk about AI or generative AI, we're talking about generative AI, but we're talking in the context of agentic AI, generative AI, whatever is going in the market right now. That's what we are talking about. So we might use word changes interchangeably, agentic AI or generative AI or AI as such. Okay, over to you, Prashant.
Yeah. Thank you. Yeah, so these are the key points that we'll be discussing: strategic planning, enterprise architectures, implementation decisions, risk management, and so on. So the entire philosophy of this program is to emphasize the strategic decision making over technical implementation. And for that reason, we have kept entire coding out of this. That does not mean we are not going to make anything out of this entire program. So as a part of some hands-on, we will also be doing some vibe coding and create some MVPs or prototypes without codes, of course. But there, the main skill set is to architect the overall application rather than, to sit down and hard code it. So we'll get it done from a vibe coder or a vibe coding platform rather than, struggling bare bones to get it implemented. So, but we need to understand what we want, and that's this main focus of the program. Okay. So the main program outcomes are design a production grade AI architecture. Of course, also we'll have a quick discussion on the compliances, both in the banking and the healthcare domain. I'll give you a detailed reading material as well if you need. We will discuss short, these concepts in short, in brief, in the next module. Yeah. So, and then how to make data-driven decisions based on model selection. What are the deployment patterns? What are the kind of different vendors offering these kind of services, from models to cloud to deployments? So you will need vendors, or you will need to talk to vendors at every stage. And then also lead autonomous AI initiatives. That's basically your agentic part. Okay. And then how to do governance, risk management. So basically AI governance and stuff like that. Okay, these are the 9 modules at a high level. We will be starting with the GenAI landscape today, and where the main focus is on the model selection strategy. How do we select models for the right use case? And again, we'll try to not get into technical discussions about the architecture and so on, but a high level differentiation of the models with respect to architecture will still be done, so that you have a decent idea that if I say this model is more suitable for this kind of application, you have that confidence. Okay. Again, in the next module, where we are going to talk about the enterprise architectures, how the entire application is created, orchestrated, you can say, and then how to implement the security stuff, okay, compliance and those things. And third, we'll go beyond regular naive prompting that you might have been doing on ChatGPT, Gemini, Claude, and so on. So we'll discuss about some of the advanced prompt engineering techniques. Some of them you might already be knowing, like zero shot, few shot. We'll also discuss about chain of verification, reflect pattern, react pattern, and so on. And I'll give you enough use cases which we will implement in the live session and get convinced, yes, that works. We'll typically use the playground versions rather than the API versions of these models. Okay, so many of these come up with a playground where you can actually type down your prompt and you can get the instant responses. Fourth module is all about orchestrating or architecting an entire enterprise grade retrieval augmented generation RAG system. Okay, so we'll discuss the different components. What are the nuances in each of these components, and then we'll see what all options do we have, and followed by the most challenging aspects of the RAG. How do you prevent your system from hallucination, accuracy, score, faithfulness? There are different metrics by which you can judge how good your RAG system is, how robust it is. Okay, so those metrics also we will discuss towards the end. Okay. Next is these validation and governance metrics. So this is again an extension to the RAG system where we are not only validating the entire system, but we will also learn about some of the metrics, how to judge how good a model is for a given task. Okay, so there are some metrics by which you can rank some of these models which are given to you as a choice. Let's say your organization has whitelisted these 4 models, and then you are free to select any of these 4. So how do I, judge which is the best model for a given use case? So those kind of metrics is what we are going to learn here. Okay, and cost is not just one of those factors, but I'm talking about the technical performance metrics here. Okay, and then once we know that what is RAG, there is another concept called as fine tuning. So at a high level, we will see what is fine tuning, what are the advantages, what is the value proposition that fine tuning brings to the table. And then you will see that fine tuning is like a very sharp sword, which literally can do a lot of stuff. But then people get confused that if fine tuning can do so many things, why not go ahead and do that? So that is where the decision metrics will be very, very helpful. Okay, so just having something does not mean that we have to use that. Okay, or knowing something doesn't mean that it will be equally applicable or useful in all of the applications. Right. So this decision matrix is something which we will dissect very closely, very clearly, and you have a very clear idea about what kind of framework to work on for what kind of scenarios, when to build versus buy, and basically right tuning, RAG versus fine tuning, or both if that is needed in the worst case. So once you have your application or a model in that case, okay, let's say you have a fine-tuned model, and then is that good enough for deployment? Is that good enough for directly being used in a LLM application? How do you make sure that your model, which is fine-tuned, is trustworthy? It actually complies with all the regulatory norms of that industry? Or is that model giving the responses in the format that the user wants, in the tone that the user wants? So how do you align the model's responses based on the user's preferences, user's instructions, regulatory norms, policies, company policies, and company branding? So these 5-6 important things are there. That is where we want to learn about the techniques of model alignment. So model alignment comes even after fine tuning. Okay, what are the different techniques like RLHF, RLAI, and so on? And then automatically the alignment tackles the case of ethics and bias. So that is one of the major reasons every model vendor will do an alignment before they are released publicly or even for an internal use, so that they want to make sure that the model's outputs are bias free and they are ethically acceptable. Finally, we'll also discuss about what are the agent, what is an agent, what is agentic AI versus Gen AI, and then what are the different frameworks, what are the kind of problems which are solved by agents, how is an agent different from a typical Zapier workflow automation. So those kind of differences are very, very important these days, because everyone says everything is an agent now. Okay, so that differentiation is very apt, that we will discuss there. And then finally, once we have created our application, which is based on RAG, or it could be based on agents, any LLM application that we have created, the next logical step is to, of course, deploy it so that it can be used internally or towards your customers. So then, of course, most of the deployment will happen on the cloud systems. So what are the different cloud services available across all the three major cloud providers? And then how do we select the optimal cloud provider based on the infrastructure, needs, scalability, cost? So all those pros and cons we'll discuss. So that will help you to select the cloud platform, much better. So this is the
Prashant,
overall idea. And
two points, couple of things. Sorry, can you go back
yeah,
to the previous slide? I'm going to look at some of the questions as well. So a couple of changes I'll suggest. So earlier we were only doing AWS, Azure, Google, but since then we were initially planning there was one more cloud provider came, Oracle's.
Oracle.
Anyone from Oracle here who's doing Oracle? Can you unmute yourself and say if you're doing Oracle? Because a couple of guys joined, or anyone or no? The guy, no. Okay, so we'll be adding Oracle as well. Number one. Number two is, I think you mention you do AWS and Google, but not Azure. Is that right? Or you do Azure?
No, we will be doing all three.
No, but we're doing all three, but we're going to add Oracle as well. So if you can update in Oracle here as
Yes,
well, we're going to
I'll do
bring
that.
Oracle.
Yes,
But
absolutely.
then I think there was one you saying we're going to bring for this particular thing. So it's my team. Okay.
Sure.
Over to you next,
So,
Prashant.
yeah, thank you. And yeah, I think I have very much explained, the foundations of all the learning path. And so let me just go through this quickly. So GenAI landscape is what we'll be discussing in the very first module about all these architectures, what to use when. I'll just read out the main learning outcome. So this is very important. Identify which type of AI model is required for a specific business use case. So that clarity has to come. We'll be doing a lot of quizzes. So please be prepared, mentally, physically, with another device if needed, like a phone, maybe to scan a QR code which I'll be projecting. I normally would be using Mentimeter. I've got my quizzes ready even for this section. So we'll use quizzes during the session plus at the end of the session, both. Okay. And we'll have a leaderboard just to, gamify things. Okay. Second module, the major focus is to design a high-level infrastructure which will balance performance, cost, and regulations. These are the main learning objectives. I'll give you some study material if you need for following on these regulatory norms and policies. Prompt engineering, as I mentioned, will go beyond the normal COT, TOT. We'll also see the implementation of chain of verification, prompt decomposition, reflect pattern, react patterns, and so on.
Just
The fourth
before we
module,
before go, can you go to the previous one? Guys, any of those guys who are coming new, don't worry. All these concepts, if you don't understand, there's a basics cover. We cover additional classes. So again, be attentive in your WhatsApp groups. We run basics of AI, generative AI. That's where we cover what is, for example, what is even prompt engineering means. How do you do the basic commands? Similarly, if you go up on top, you were talking about what is LLM mean, what is LangChain means, what is LangGraph means, what is GAN means, what does transformers mean, what all those things. So all those, what is the even model means, all those, there is a session happening called AI ML for beginners. You also have access to that course. You also have recording of those, and you also have a live interactive sessions, AI for beginners. So all those things on all those things you'll be getting a hang of or introduction about all those things. Just wanted to tell. This is again, as I said, I want to keep it high level. I don't want to go on a lower level or what does even basic things mean. Over to you. So Prashant, just to give anyone ask, there is a session happening. That's where they should be going.
Sure.
Okay.
Yeah.
Over to you.
Yeah, and then as I already mentioned, we have a detailed module on RAG. So where we will see how we can build a RAG system to leverage internal proprietary data, which never made it to internet. So these models have never seen that kind of data. So they will never be able to answer those kind of questions that you would be having in your internal knowledge base. So how do we build a chatbot which can be used to query that internal proprietary knowledge base? So that's the whole idea behind this module. There are different components, 6 components. What are the different parts? How do we connect them? What are the different options, strategies, models, so frameworks? So we'll discuss everything around that RAG system. Okay. And then the validation of the entire RAG system along with different metrics. As I was mentioning, these are the different metrics that we'll be using to evaluate the RAG system and also the models in general. Okay. So there are some healthcare specific benchmarks. We'll also discuss about that. There are some financial specific benchmarks. So MMLU, MedQ, and so on. So this is really going to be useful for people who are coming from these two biggest domains, I would say. Majority of the learners are coming from these two biggest domains. And then, of course, decision matrix. Okay, we want to make financially sound build versus buy decisions so that our entire system is robust, and it shouldn't happen that because of the fear of missing out, we created a overly complex system which is now so costly to build, to monitor, to validate, and even to deploy. And I mean, that could have been that kind of task could have been done from a simple machine learning system. So we shouldn't be getting to that overly complex systems unknowingly. Okay. So we need to have definite use cases to make it complex. Okay, and then finally alignment, where we will understand what are the mechanisms used to control the behavior of these AI models. I was talking about AI ethics and bias removal and so on. So that is all done by alignment. If you remember, just to give a quick context, even today, if you go to DeepSeek and ask about which are the northeast states in India, DeepSeek will blatantly refuse to apply. Are there any cross-border conflicts with China and India? It will simply refuse to reply. Okay, because these DeepSeek models have been aligned, they have been trained, they have been specifically instructed not to answer any China foreign policy specific kind of questions, which puts them into a bad show. So that is exactly the topic here that we'll be discussing about the fairness, alignment processes, and so on. Okay. And then about the agentic workflows, we'll be discussing about three main platforms. One is the LangGraph, CrewUI, and the third is AutoGen. Okay. And then finally, the cloud deployments, the options, what are the services in Bedrock, what are the services available in Azure, and again, services available in Gemini. And again, as Atul pointed, we'll also include Oracle in this discussion. Okay. These are the main strategic capabilities that we are going to develop. Anyway, I can share this slide deck and you can refer to this at your
So
time.
what we're going to do is, Prashant, we're going to put it into the portal. Inside the portal, we're going to cover that. So everything will be there, so you don't need to worry, and we'll be constantly updating and revising so that we update on. Okay.
It has been already updated, so let me share the link.
Then okay,
no worries.
perfect.
Yeah.
So then I'll skip the remaining part. You can just go through it. I think we can directly start with the module one.
Now, one question I will say that is, guys, if you are reading a terminology or concept, make a note of this and ask in our WhatsApp group and community what does it mean, because that's already covered. That will be already covered. So what is LLM, for example? If you don't understand, don't keep it yourself. Don't ask it here right now because it will disturb everyone. Ask in our WhatsApp group or in community. Most probably better is in community. We'll have another platform, also the beginner level. But make a note of these things. I need to understand. What I do is I hear a term, I go to either nowadays you can use Claude or ChatGPT or Google itself. What does it mean in a simple layman's term? And that's how you can go deeper into if you want.
Okay, let's get started. Yeah, this is the overall agenda. We have these 5 main pointers to cover in the module 1. First is understanding what is AI. We'll not get deeper into all that discussion, assuming that most of you already know the focus will be on the architecture side, the business impact and strategic discussions. Okay, but anyway, since some of you might be a bit new, I'll try to explain 1 or 2 lines as basic as possible so that it becomes relevant and comprehensible to everyone, right? Yeah, so these are the main points. You can say module number 1.1, 1.2, 1.3, 1.4, 1.5. That way you can say, right? And of course, the majority of the discussions will be around the BFSI and healthcare, at least in the slides. But as far as my knowledge experience goes, maybe I can take questions from the other domains as well. And if they fall within some of things which I have already known, I'll try to help you out at best. Yes. Okay. So overall, this AI is the broadest domain which deals with creating systems or machines, you can say, which can think autonomously, which can plan autonomously, which can, take action autonomously. What do you mean by autonomously? Without being explicitly programmed or explicitly told what to do in what kind of scenario. So if you have created a system which is able to make decisions and execute those decisions in real time, okay, based on the scenario, based on the historical data, based on the environment, then you have created an AI system. That's how I would define what AI is all about. Okay. And then smaller part of that AI is machine learning. So in machine learning, again, the main USP is based on the historical data. We will make some model. Okay. So there are three words. One is data, one is algorithm, and one is model. Okay. I'll just quickly write these three words on the screen to show you the relationship between these. And so that relationship is important because I'll be referring to these three words over and over again in my entire next 10 sessions as well. Okay. So data is what we have. We are calling it as historical data, whatever last 10, 15 years data that you have. And then you have something called as an algorithm. Okay. So algorithm means, so basically what we want to do, the machine learning algorithms or machine learning systems or AI system, whatever, the overall objective is to create or the overall objective is to teach the machine what has historically happened, what is the pattern in the historical data, and assuming that the same historical pattern is going to persist in near future, may not be 10 months down the line or 10 years down the line, at least in near future, assuming that the same pattern is being consistently followed, can I create a system which can be used to do a prediction? So what we are doing is something sort of a predictive analytics. Okay. So analytics as such itself has 3-4 levels, I would say. One is descriptive analytics, in which you are just describing what is the pattern present in the historical data. What are your key findings? What are something unusuals? What are the abnormalities that you found in your data? That is basically descriptive analytics. You are just describing statistically by using visualizations, graphs, plot, pie charts, stack plot, this and that. Okay. That descriptive analytics. Next level goes is basically what we call as detective analytics. What does that mean? Now that you have found some abnormalities in your data, you have found some special things which probably were unexpected, then you want to go deeper and find out a reason for that. So that is where the detective analytics start. Okay. So descriptive analytics followed by detective analytics. And then the third level is your predictive analytics, where you start making models. You start making models. Now, what do you mean by model? Model is basically the representation of the learning of that pattern present in the historical data. That is called as the model. Okay. But how does the machine learn? The process of learning is outlined step by step in what we call as the algorithm. So now I'm going to connect these three. So when you run an algorithm on data, it's like y is a function of x. Okay. So when you run an algorithm on data, what you end up is a model. Okay. So algorithm is the process of learning the historical pattern from this data. That process, those steps, those calculations, those mathematical calculations, linear algebra, whatever it is, okay, they are all a part of the algorithm. So when I say a machine learning algorithm, then I'm referring to the steps which are being used to learn the historical pattern in the data. After that pattern has been learned, that representative pattern or the relationship in the data is called as model. So model is the learned thing. The process of learning is the algorithm. This is the process of learning, you can say. Okay. And this is the learned representation of the machine. So if I just ask the machine, tell me what have you learned or show me what you have learned, then the machine shows me, yeah, this is the model. So model is the learned representation ultimately. So now, which clearly means that in future, if the data changes, even though your algorithm remains the same, your model will still change. Conversely, if your data is same, but you change the algorithm, still your model would change. So if I say that we have 20 different machine learning algorithms, even if they are trained on the same data, okay, I'll end up with 20 different ML models because each model has its own unique way of learning things. Okay. So at the end, whatever they have learned would be different, even though the main pattern still remains the same in the same data. Okay. So that is what we have to understand. So when these patterns become complex, okay, that is the main USP. when the complex patterns are encountered. So when do you encounter complex pattern? Very natural question. Whenever you are talking about text data, whenever you are talking about image data, audio visual data. Audio visual means your audio video kind of thing, okay? Or a combination, let's call it as multimodal. So if your data is a combination of text, image, and audio visual thing, that is your multimodal, then the complex patterns arise. That goes beyond the learning capability of the standard machine learning systems. And that is the good reason to start exploring neural networks for learning. So who is learning now here? The neural networks are learning. So when I say a deep learning technique is being used, essentially I'm employing neural networks for learning. Here also you'll get a model. We'll call it as a deep learning model in this case. Here I'll call a machine learning model in this case. Who has learned? The machine learning algorithm. And here in deep learning model, who has learned or what has learned? The neural networks have learned the pattern. So it is that simple. So machine learning algorithms will result in ML model and neural networks will result in deep learning models. Okay. But remember that every single job of machine learning can be done by neural networks these days. Okay. But that does not mean that you start using deep learning in every other business use case because they are meant for complex cases. Okay. Complex patterns. The data requirement is more than 10x to 100x for the same use case. So unless and until you have a really huge amount of data, please do not ever think to use neural networks. So they are not the go-to choice every time. Okay. They are the worst case scenarios, I would say. If you cannot use machine learning for a given task, then only start thinking about deep learning. So that is the whole idea. But now there was a blocker here. What have we discussed just now? If I just go with the hierarchy, what have we discussed till now? We discussed about descriptive statistics, which is what everyone was doing. Then people went into detective analytics, correct? From there, we went into predictive analytics. Predictive analytics is all about machine learning models, deep learning models used to make future predictions. But that is where the blocker starts because you can only predict what will happen tomorrow. Let's say whether Nifty is going to give a gap up opening or a gap down opening. My model can predict. Whether it is going to give 100 points up or 100 points down opening, my model can predict. What will be the sales forecast for the next 2 quarters? My model can predict. Whether it is time series data, whether it is a classification model, okay? Whether a system will fail in the next 3 months, my model can predict. But these are predictive models ultimately. Okay, whether there is a fault in the manufacturing conveyor belt, my model can predict if there is a fault detection. If the credit card transaction is fraudulent or genuine, my model can predict almost in real time. Okay, but people were not satisfied with this much capability. They wanted more. Dil mange more. Okay, and that is what the generative capabilities were lacking. We were not able to generate content. We were not able to generate images, text, audiovisual data. We were only able to predict and classify. Okay, this voice belongs to Prashant. This voice belongs to Amir Khan or Salman Khan. This image belongs to Atul. This image belongs to Shahid. Okay, so it were able to predict. This is a cat image. This is a dog image. Those kind of classifications, those kind of predictions were being done. Even the systems were intelligent enough to give you recommendation systems like what happens in Netflix. Okay, based on your watch history, browsing history, click history, everything is being captured. In fact, every single mouse click, that is what we call as click stream analytics. So every single mouse click is being tracked by those cookies. You may accept it or reject it, but they are doing that tracking. Okay. So all that click stream is used to understand the user consumer behavior, consumer liking, consumer demographies. Okay. So that more customized recommendations can be given. But recommendation is what? Ultimately, the system is predicting what you would want to watch next. That is the meaning of recommendation, right? The system is recommending. What does that mean technically? The system is predicting that, okay, since you have watched Star Wars, you might want to watch Armageddon. Okay, something like that. Okay, since you have watched these three movies, probably his liking his taste sci-fi or romantic comedy and so on. Okay, so the system is learning in real time and trying to predict. That's again a recommendation system. But these are all predictive in nature. They are not generating any data from scratch. And that is all about the generative AI. So this course would be heavily focused on Gen AI, where that's what the title of the entire program is, Gen AI for business leaders. Okay. So then we will see what kind of models are. Obviously, these models cannot be ML models and DL models. They have to be a new class of models which have emerged late 2014, I would say. Okay. So 2014 onwards, we saw the emergence of generative AI models, which were able to truly generate content. Okay. Content could be text, images, or even code. And where are we going to potentially use them? That's the overall discussion in this program, I would say. Okay. Now that we have a model, we'll wrap that model into an application. And then how do you architect an application? Where do you deploy them? How do you monitor them? What are the cost benefit analysis, TOC, total cost of ownership? So those kind of discussions we'll be having subsequently. Let me pause here and see if there are any questions. You have to be very clear with these
No,
evolution, at least now.
no, brilliant work, first of all, Prashant. Very good job. I think anyone have any questions, this is the time we'll have unmute, but please keep it in the context of this discussion so far we have done. I don't want to go anyone on future proofing or something. That all will be coming. One question is when we talk, I think you mentioned about huge amount of data. They're saying what is huge amount? Is it petabytes, gigabytes? My view is it's relative, but then depending on what kind of a model you're building, who's building, what kind of a use case you're doing. Sometimes even gigabytes is small, but some cases gigabyte is huge as well. So depending on it's all relative. But anything you want to add, Prashant, on that? That's the
Yeah,
only
yeah,
question.
Yeah,
absolutely.
before I was just,
Well,
he had mentioned, sorry to interrupt, guys. He had mentioned between machine language and deep learning that if you're going to use a deep learning model, you'll be dealing with large data. So I was trying to see what is large, at what threshold do you define what is large for deep learning use case versus ML use case? That's all. Thanks.
Yeah, yeah. So
thank you.
I would like to add one quick line here. Okay. So these are the kind of interview trick questions. They are trap questions, I would say. Okay. Where they would, you know, somehow uh, compel you to come up with some numbers, but try to resist as much as possible because you have to be diplomatic. It depends on the use case, the kind of data that you are having, the kind of modality of the data that you are having, and what is your end application all about. So there is no lower limit or upper limit, so as to say, but one thing is very clear, the larger the better. Now it can go to few thousand data points to even billions of data points, but millions to billions of data points, that is what everyone already uses in deep learning scenarios. Okay, but again, as I said, that itself can again not be sufficient, depends on the use case. So try not to come up with a number unless and until these 4 or 5 things are given to you, let's say. Okay, for a given use case, for a given domain, for a given modality, for a end task. You have to also define the end task, whether you're looking for a classification problem or a regression problem, unsupervised, supervised. What is the problem you want your deep learning model to solve? If that is also not clear, then don't jump to a number outrightly, because that is something which is a bit tricky. Okay.
No worries.
Perfect.
Thanks, Prashant. We'll go quick on one or two more questions in short, if you can do, so that we can move
Yeah.
on. Is deep learning a subset of machine learning? And if
Yes.
there are algorithms on both the sides? Answer is yes. Let's move on. Whatever I can answer, I'll answer that. And if you want to add something, you add something. Okay. Over to you. Yeah. Just if you do a quick one or two liners, over to you, Prashant. Yeah.
Yeah,
Again,
yeah,
as I said,
absolutely.
I
So
don't
this
know.
is
I
the
don't want to.
broadest domain. That's
Yeah.
why I added this kind of
Exactly. So biggest is AI, below that machine learning, below that deep learning, and then below that is generative AI. Again, we cover all these in our beginner level classes and as well. Okay. Next one is about, I think, one second. I think Shahid has already mentioned. There's one more question was about agentic AI. Are we treating Gen AI and agentic AI same as per the slide, or yet to be covered agentic AI? Where do you put agentic AI in this again? we are again going deeper, but lower level. Over to you. Yeah.
Yeah, so Gen AI is the broader domain. Agentic AI, I would say, is a smaller part of that Gen AI. Correct.
Yeah.
When we are using agents for orchestrating the entire application, that is where the agentic AI starts. Yes.
Okay, great. Jakaria, we're good. Yes, session is recorded. Shruti, we are going to look at these models. So these models will be coming. Later we go deeper. You will see what is the generative AI models. There are tons and tons of model in our, if you're part of AWS Azure or Agentic AI, when we go deeper, you're going to literally use those models and build something, generate something, develop something. We're going to look at machine learning model. We're going to look at deep learning model. We're going to look at generative AI model. All those we are going to do different use cases. So actual implementation will come in a separate program that you should already be part of, Shruti. Okay, you'll be seeing these actual implementation, how to leverage them. Okay, I'm not going to Sharath, I'm not sorry. Hold on a second, 1 second. Please put your question again in the group. I'm not going to discuss anything on unmute because we have strict timeline I'm going to cover. We'll take the questions on logical point.
Yeah, thank you. So yes, the slide deck would be there, and most of you can refer to this. Now, this talks about the different applications these traditional models have been doing. So when I say discriminative model, I'm talking about the predictive analytics. Okay, to discriminate this or that. So basically, any given use case, for example, here fraud detection. So any transaction needs to be classified. Okay, whether it is fraudulent or not, any credit card transaction or any point of sale transaction could be, or for example, credit scoring. This is a case of regression, not classification. For a given customer profile, for a given transactions that this customer has done, different credit history that customer has been having, can we assign a score between 300 to 900? So that is a regression problem. So based on the historical financial data, and you can use that number for granting loans and so on. Customer churn prediction is another fantastic use case where you can predict based on the behavioral patterns, demographic details, whether the customer is likely to stay or leave. So when the customer is likely to leave, that term is called as churn. Okay, so churning out means subscribing out of the service and so on. And if the system is predicting that, okay, these are a few folks who are going to churn out in the next month, then there can be the business will devise some retention strategies and so on. You can read through this. Let me know if you have any questions in the chat. I would also suggest me to add in that chat group if possible, if there are some technical details, if that is not being able to answer by the team, but I'm very sure that the team will be able to answer most of these questions. But just in case, if that is needed for me to come on top of it, I'll be happy to do that.
Ishad, just one more question if you can take, because this is coming repeatedly, so I want to done and dusted it. Agentic AI, does it come under Gen AI? Just a 30,000 foot view about again.
Yes. I would say agentic AI would come under the generative AI, because ultimately agents are going to generate something using these LLMs. So you cannot create an agent using an LLM or a model. Let's say, what kind of model? This could be a text generation model, or it could be image generation model, or a sound vision model, whatever, or it could be a multimodal model. Agents are powered by models. What type of models? Not the discriminative AI wale models. They have to be generative models. They are powered by that. But is that all? Answer is no. So you need to have model plus something. You need to execute. And that is what the agentic AI is. If you are only accessing models, you have created a simple LLM based application. Okay, that's a simple LLM API call. You have not created an agent. An agent is supposed to take an action based on the reasoning and thinking and the conscience and the prudence of that model. Whatever the model suggests, you should be able to put that into action. That is what I would define as an agent. Okay, so yes, agent is a part of Gen AI, a very specific subset, I would say. And we have our agentic program coming up. And all this knowledge would be definitely helpful there.
Guys, again, we are going to go deeper into these topics. This is again, we're keeping high level. When we go deeper, we'll learn these, actually implement these. You'll see in action these things again just coming. Now, having said all this, I would highly recommend you to watch this session one more time, make list of all the questions that you have and see if you can answer. Because in our FAQ section, in every session we have done FAQs with tons and tons of FAQs. We can answer or bring them again back here. Because again, as I said, I want to make sure that everyone's time is being wisely used. And we ask questions which only Prashant can, or like, of course, anyone can answer and Prashant can answer pretty much all of them, but then I want to use his time wisely as well. Okay. But don't worry, we'll make sure that all your questions are being answered before we finish this program. Okay. Or in some doubt removal sessions. Over to you, Prashant. Next. Yeah, please.
Yeah, thank you. So yeah, these are a few applications of generative AI, as we have already seen. I'll just call out one or two just in case. Okay, so where we want to generate something, that part should be very, very clear. Here, one example is a report generation. And what are we generating? You can generate financial reports, investment summaries, templates. You can say compliance documents, summarizations can be generated, and so on. Okay. Business impact, of course, a lot of manual effort used to go in creating these things. Documentation, product documentations, user manuals, technical documentations, they're also a part of it. Not everyone wants to, create a user documentation, something, user manual. Now, all of these are getting heavily automated by using these generative models. They understand the system, they understand the architecture, and they will document each and everything systematically. Probably even better than a human these days. Okay. Customer communication, like think about your chatbots or personalized emails, interactions, product recommendations. You can also create marketing emails, flyers, those kind of thing, and scale one-to-one communication, because you can also provide context about every customer while generating a customized email. Okay. So every customer will have a different requirement, would have a different interaction history in past. So you don't want to start every time with the same copy paste template applicable for everyone. Let's say I've already called the customer care 4 times and they already have that on record. Why not give a email communication which mentions about what I have communicated, and take it further to an actionable step, rather than same copy paste email which was given to Atul. That way, clearly I can discard, because this is just a copy paste email. Everyone can figure that out, and that becomes just a waste of time, money, and effort. Okay, so that is very, very important these days.
Just on this point on customer communication, if you see those who are part of, again, AI Full Track, we have a project. I think some of you guys already done. Brilliant. It's again done by Prashant. This was a customer agent where we are doing two things.
Yes.
One is the actual use case of the train, like the agent. What is basically the answers related to that particular use case, the order, or where is the order, what happening with the order, and also sentiment, not just order, which is very simple, people used to do it, but also sentiment with that question. Is a person very upset, the client is upset, happy, neutral, those things. So make sure, if you've not done, brilliant, end to end, right from how do the use case starts to the actual development, to the coding, to the deployment. And again, you don't need to even code. If you don't know, if you're not a developer, we are going to look at later part. We're going to see vibe coding, which some of you guys are hearing. If you're an architect, you shouldn't be doing coding, vibe coding, or you can even ask the generative AI to write the code for you. So we'll tell you how you've written as well. So make sure that, we'll give that link inside, again, WhatsApp group. We'll share those links. If you're part of AI track, we have done that. And some of you guys have done brilliant session of feedback. Santosh, initially we had some technical glitches, but then now multiple guys have done it and they love it. Similarly, each of these which you see here, there's a hands-on specific to your use cases within. We have done it both AWS and Azure, both report generation, code generation, synthetic data. In fact, a lot of these model which we are training are, if there's not enough data, which is common problem, business problem happening, even AI will generate the data itself, synthetic data, and train the model based on what you tell it to do. So there is some labs around synthetic data as well. And of course, content personalization, you've already seen. A lot of our emails that we see in marketing, a lot of pages we see now, a lot of question answers we didn't think. So we give it to the Claude, both Claude, Gemini, and ChatGPT, and say, hey, I'm doing this, predict what questions might come, and create an question answer section before we know what questions are going to come. So a lot of these things are already implemented. A lot of companies are doing. We have labs around all of those as well. Yeah, so Anmol, we are going to do the vibe coding. We are going to cover in this program towards, and we are going to do vibe coding as well. Okay, so whole project we are doing, prototype we are doing, we are going to develop that using the vibe coding as well, because we are not developers. Over to you, Prashant. Okay, thank you.
Yeah, thank you. Yeah, you can go through all these. That's pretty self-illustrative. I have tried to, give a finer detail so that this becomes explanatory as a reading material as well. That's why, So the main, if I want to summarize in one line, the main strategic advantage that you would have by using GenAI is that GenAI multiplies your human productivity by automatic content creation tasks. And that also nowadays maintains a very high quality and a great level of customization depending on the use cases. So that's one line summary of what GenAI is all about in different domains. Okay.
Okay, guys, now if you don't understand what is a diffusion model, this is what we're going to cover. GPT-4 model,
Exactly.
or what is an encoder model, or fine-tuned BERT model. This is what we're going to cover. Brilliant.
Which is why I clearly said I'm going to make you uncomfortable, because I just wanted to check how many of you are knowing these things. And of course, this is a pure classification task, the perfect for encoder only models like BERT, in fact. But you can also go for GPT-4 models that is 100x more expensive and slower. So this is like a sword and this is like a needle. If you want to do stitching, you will use a needle, but I mean, this will be a overkill, I would say, over engineering solution. But yes, in principle, you can still use a GPT-4 model as well. Okay, diffusion models are for images, and T5 is overkill again for simple classification tasks. Typically, T5 models are used for summarization tasks or translation kind of tasks. These are the things that we will be learning in the next few slides. I take just to check.
Okay, the question is, which of the following is not a generative AI application? Creating a personalized marketing email, detecting fraudulent transactions, generating code, or producing synthetic customer data for testing.
So just in case you are not able to see this question, just reload. There might be a button called as reload also. So if your handset screen doesn't sync with my screen, just reload every time. That's the standard way. And if you don't respond in time, it will show you that you did not respond in time. Because as I already mentioned, these all things will come with a 30-second timer. So fraud detection is a discriminative AI classification task standard. Okay. All others are going to generate new content. Okay. So creating personalized marketing emails for 10,000 customers is a generative AI task. Generating code from natural language requirements, like you mentioned, I want to have a code for generating or analyzing pivot tables using pandas. So that's a generative AI task. Producing synthetic customer data for testing. Okay, that also you can request ChatGPT, give some format, whether you want it as a JSON format or a CSV format, and it will give you a synthetic data for testing. So these are the three very standard tasks of generative AI.
So in a simple terms, if you're generating something, whether it's data or image or video or graphics or multi-model, that will come in a very simple terms. Again, don't worry, because that's what we are going to cover in this whole
Right.
program about is so that you understand difference between generative versus other things. Over to you, Prashant. Yeah, thank you.
And I can promise that a lot of learning is hidden in these quizzes. Actually, these are not just to test; these are to augment your learning as well. Okay, so many times when I have to uh, just make you more attentive, I'll just put up the quiz. Okay, so there will be some new things which definitely will differentiate some of the people who might be knowing. They will have some unfair advantage, but don't worry on that. Okay. Fine. So let's catch up. We are going to discuss about the decision frameworks next. Yes. So this is the decision framework. You can go through this. I'll just highlight the couple of most important ones. Okay, what discriminative AI does versus a generative AI. So if you see the broader question that is answered by a discriminative AI model. Okay, I think this is now much better. Okay, so what category it is? So it's like a classification. Okay, so fraud detection was a case of classification. It's a standard discriminative AI task. Generative AI, where you are generating new content. Now here, one important point that I would like to highlight is every time I've been saying generate new content, new content, new content, or generate content. But is a model really going to generate a new content? Answer is no. No model can ever create a new content which it has never seen in its training data. So let me give more explanation on this a bit with an example. Let's say the model has never seen how a cat looks. It will never be able to generate cat images in various scenarios, scenes, and doing different activities. Let's say you are saying, give me an image of a cat walking on a beach. But the problem is model has seen a beach. The model has never seen a cat, how it looks like, whether it is an animal or a type of table or a type of a tree or a plant or a type of a human being. The model has never seen that. So it cannot imagine cat. So whenever we say new content, it's not being imagined out of thin air. It's only rewiring of the existing things. Okay. So these models would have been trained on almost everything which is publicly available on the internet. And so we can be safe to say that these models know everything. Okay. But just imagine that if you are asking the model to generate an image of an alien or something which is only there in your mind, which is only there in your imagination, your model will not be able to generate anything of that sort. Okay. So that is the main important thing. So your model has seen billions of emails, so it will be able to generate an email. Your model has seen, millions of poems and stories and lullabies and everything. So your model will be able to generate a variant of that. Okay. The model has seen billions of code blocks. So your model will be able to generate code blocks for different tasks. I hope this makes it very clear, right? So model cannot generate anything which it has never seen during its training phase. Is that clear? Can you just type clear in the chat? Is that part very clear? Now, because that would be like expecting too much from a model, right? Ultimately, it's a machine. It needs to be trained, and we cannot expect it to, just imagine things out of nothing. Okay. For a BFSI, is that transaction fraudulent? That's a discriminative AI task. Generate a personalized loan offer letter. So each word or each sentence is customized to the customer profile. Let's say that is a generative AI task. For a healthcare, one example I've given is this X-ray showing pneumonia in the chest or whatever? So that is like yes or no kind of an answer that we are expecting from a discriminative model. Whereas a generative AI model will be able to generate a patient-friendly discharge summary or even summarize your clinical reports or pathological reports. You get your blood test in 30 pages with all those 200 parameters. So your AI model will be able to generate a human readable, a layman terms summary for you, like a 5-year-old kid being explained what that blood report is all about. Right? That is where you would actually use a generative AI model. Fine. Okay, this is a very clear thing. When you want to classify or categorize your existing content, that is where your discriminative AI is. When you want to create anything new, that is where your generative AI is. That's one line, clear distinction. And then you can talk about human creativity, more quality, personalization, content variety, and everything. That is where the generative AI stuff comes into picture. So example use cases being again report writing, customer emails, clinical notes, code generation, marketing content, patient education, and so on. So I've tried to mix both banking and healthcare domains at least. And let's see. Okay. Going further again. Now talking about the models in generative AI. So there also we said we will be having models. 3 categories of models we would have. One is the language models. Now, whether they are large or small, so language models can come in varieties, a small language model or a large language model. Typically, larger the model, the better it is. That's the general perception. Typically, GAN models and diffusion models for generating images. Sorry. Okay. So here it is image generation and image enhancement. That is where you would use a GAN model. Okay. So GAN model, let me give a very simple example here. Okay. If you are wondering what a GAN model can do, just open this page. This person does not exist. I just am searching. Okay. This person does not exist on Google, Bing, whatever your favorite search engine is. And you'll get several pages with very similar URLs. Okay, let me randomly take one of them. And this face that you get to see is of a person who never existed. And see the level of detailing now. Okay. And now you can even generate different genders, age, ethnicities as well. Okay. You see, can you see here? This
Yeah,
is
it
an
looks real,
artifact.
real girl. Yeah. Yeah.
These are some artifacts. Can you see? Now, as an expert, I can instantly highlight the artifacts, which are AI failures. This is an artifact of AI failure. If you look into the eyes part, that is fantastic good. You see this part, overflowing. So you can point out, definitely you can point out. Okay. So this is all done by a GAN model. Let me tell you, most of these websites are powered by a GAN model, a generative adversarial network. Okay, that is what we call it as a GAN model. Okay, and this GAN models work on a very simple philosophy. It will be pretty interesting to see GAN model, how they are trained. Very simple. I'll just go in one of the images here. Okay, so we have um, two networks. One is a discriminator network. If you see, let me just, and there is a generator network. Okay. So everyone, it's a bit technical, but very interesting scene. Okay. How a GAN is. So GAN components, there are only two components. One is a discriminator network. It's a neural network. And the other one is a generator neural network. So both are neural networks. So two neural networks which are competing against each other. Yes, Shahid, thank you so much. Okay. So I think I'll use Shahid's image. It's there. Perfect. Yes, yes. So usually I get it it depends on days again sometimes. Okay, fine. So this GAN usually has two types of networks. And one is, as I said, there is a discriminator. So this is my discriminator and there is a generator. So the generator network will generate fake images. Like this person does not exist. That's a fake image, which I had used to show that in the website. Okay. So you are generating continuously fake images. So in this case, the fake image is that of a currency note. Now the discriminator network is already given good amount of data of real images, how real people photographs look like in that case, or in this case, how real currency looks like. So the job of the discriminator is to differentiate that any new sample that is given to the discriminator, it should be immediately able to tell whether this is fake or real. Okay, so you are training this guy with continuously new data. Now the new data will be both the real data as well as the fake data. So let's say in the first iteration, this guy was given a fake sample and this guy said, okay, this is a real currency. That means there is a mistake on the part of the discriminator. And here the generator has got 1 point. So it is a 1-0 now. The score is 1-0. Okay. Now the discriminator said, okay, I was not able to discriminate. I probably was missing out on something. Okay. Some neural network changes. Okay. And then in the next iteration, okay, it was given a real image and it was able to find out that it is indeed a real image. So again, that 0 score becomes 1. The next iteration, this was given a fake image and now it was able to differentiate that as a fake image. That is now 2 and now this is still 1. So back to back, we keep giving real images and fake images, and every time this is able to differentiate, its score keeps on increasing. Okay. And if it is not able to differentiate, then the score of the generator increases. So they are like competing networks. They are competing. So the generator wants to become better so that the discriminator is not able to discriminate whether it is a fake image or a real image. And the discriminator wants to become better so that it is able to immediately identify this is a fake photo of Prashant and this is a real photo of Prashant. This way, the overall objective is to generate images which are as good as real. That is the overall objective. So if you train these a few number of iterations back to back, after the model training, the GAN network will become so sophisticated that the real images and the fake images it will be very difficult to differentiate them. The fake images will almost look realistic. So that is how models learned to create realistic images for the first time. They were generating these images from random noise. You can see the input is literally a random noise. So from random noise, it is able to create an image which literally a human is not able to differentiate. And that is the level which these models have really come to. Okay. So that is how the GAN models are so proficient. But again, there was some acha. Also, we could style transfer. So style GAN means I have got a photo of Prashant in a summer season, and now I want to change that to Prashant standing in some top of icy mountain with snow falling on it. Okay, so the main character still is the same, but you want to superimpose a different theme on the main character. That's exactly style transfer GAN. Okay, and cycle GAN, fin GAN. So these are different variants of GAN which came because of the popularity of the GAN models, where you could transfer styles, you could fuse two images, you could fuse two objects within the same image, and so on. But the only problem here is these images were not very high resolution, and your starting point itself was some image, and you were only creating variants of those images. How do you instruct a model to create something literally from scratch? Let's say you want to train a model so that it is able to create an image of a cat without providing a variant of cat to start with. And that is where the diffusion models came in. Okay, they literally start from a random noise, which means you are starting with nothing, no object on the screen, and then it will be able to create a very high quality images. So that is where your DALI model, Midjourney, Stable Diffusion, these are all the names of the models which are powering your ChatGPT, Gemini, and your Bing. Okay, now these are all diffusion models. They're able to do captioning, they are able to do style transfer, image transfers, fusions, everything that they are able to do now these days. Okay, so okay, so with time I'll also keep showing a lot of my actual prompts, because teaching shouldn't get disconnected with the real application. So I will usually keep on showing some real prompts that I use for some of my use cases, so that everyone gets that confidence that indeed that this makes sense to do it this way. It shouldn't be just purely academic in nature, just for the sake of topics that we are doing it. Okay, so I have literally implemented each and everything that are there on my slides, and I'll show them from the real world scenarios kind of things. Okay.
Well, so that reminds me again, sorry, and again on that point, those who are part of yesterday, we did a LinkedIn. So we gave a LinkedIn prompt on how to write whatever you're learning, write down not just as a learning, but actually you go as an authority and say, hey, I did this. So actual prompts are there. If you've not gone through this announcement post in the group, do that, because that's very important for two things. First is building your authority with recruiters, employers, and then also write it in so it doesn't come like, oh, you're learning this. It comes as an authority. Second thing is it should not come like you're looking for a job or change, but you build an authority. And then recruiters or employers, other employers, when they see that you're doing these projects, they will come as well. And I also want everyone to do is maybe go into the group and comment each other's post, because that will build authority immediately. It will start showing to other groups as well. So make a group, and in this group, I'll say, suppose someone publish a post, put into the group and say, hey guys, what do you think about it? And go and comment their post. You ask them to comment your post. What will happen on those days? Then it will bring visibility to the recruiters, employers, even if you're not doing. So please do that. Done tons of that. Or if you tell me, if you share it with me in our group, I'll pass it on to entire, like we have around more than 6,000-7,000 members in past we have done. So we can easily, even if 10% of that goes, 600 like, share, comment is a big number. It's typically they don't happen that one. So please bring that, share us, but write as an authority. If you don't have, if you want to get your reviewed post, give the post reviewed as well. And that's how you become known within your domain or within your field, and also solve others' problem. I think there are a couple of guys in my Azure program. What they do is they look and solve other problems, issues. What they do is, and then go help. That there's a lot of learning from that when you help others' problems as well. So please do that. Okay, we'll bring on more. Thank you, Sudipto, and thanks to absolutely, Sarang. So we have and ask everyone within your group to connect with each other on LinkedIn and promote each other's posts so that you get also visibility. You go and comment on others' posts as well. Yep. Over to you, Rajesh, please.
Yeah, so this is really great program. So this is what I was expecting. So I was in the AIML training, but this is more focused on what we need, right? So I'm just targeting the architect role, and this is really great. And Prashant, that's what I want. And thank you for that's a great thing. Thanks, Atul.
So Rajesh, this is just a beginning. He has run. We are going to go further architect. So this is again still high level. We're going to go, and there is a second part which is coming after this, which is build, manage, and deploy. We're going to actually build something and design something as an architect level as well. So still okay. Thank you very much, Rajesh.
Okay. So we saw that vast majority of the tasks can actually be done by predictive analytics or predictive models, I would say, which are still a part of the discriminative AI network. Okay, the majority of the machine learning, deep learning, and even language modeling models, I would say the traditional language modeling, okay, where we used to, do some predefined tasks like classification, regression, clustering, customer segmentation, recommendation systems, and so on. You can check out these kind of use cases. In generative AI, we want to generate new content. Okay, that was the main idea, and I think everyone already has access to this. You can go through this. Okay, and this is given to you more like a study reference. I don't want to repeat each and every point in the session here. I will only highlight the important concepts. I'll just use it as a additional hand holding instead of spending time in reading out each and every point. So my strong suggestion is, since I've already shared these materials with you after the session, please go through them line by line, point by point. If there is anything which you are not able to understand, please flag it in the very next session. That requires some attention, requires some discussion, and so on. Okay, so that is the approach we'll be taking. Okay, and now that we know that for generating new content will need a generative model, there are basically two categories of generative model. One is for language part, the text generation capabilities, I would say, followed by image generation capabilities, and there could be scenarios where we wanted to take it to multimodal. But okay, let's call this also as an image generation. So image generation capabilities earlier used to come using autoencoder models followed by variational autoencoder models. You can find these names somewhere else also in this presentation. And then the last and the most advanced came as the GANs that also have shown you as this person does not exist web page that we saw yesterday. Fine. And these were all until 2017. So beyond that, this attention is all you need. That paper came that changed the LLM landscape. And then people thought, okay, if we have an attention model for text generation, can I have a similar attention model to generate images? Why not? So that is where some sort of diffusion models came in, and not only the diffusion models, we have vision transformer models also. Now that's the category number 4, I would say. And then you have multiple things coming up like CLIP and Blip and then Lava. A lot of architectures are coming now, LLAVA, Lava models. Now these are all completely different architectures. WIT is vision transformer. Literally, it's a vision transformer. Just like you have a transformer model to generate text, now you have a transformer model to generate images. Those are vision transformer. So moral of the story here is, once people recognize the generative capabilities of these models, they started exploring different advanced architectures, all based on deep learning, to generate new modalities, new outputs, new format of outputs, audio, visual, multimodal. Now these all models are multimodal. Multimodal means they can generate text as well as images combined. So think about a number plate, license number plate. It's essentially an image with text written on it. So how can we generate images with text written on it reliably? That is what the traditional GAN models or diffusion models were failing. With these new generation of models, which are truly multimodal in nature, the understanding about the images is also very deep. What is the advantage? So you can literally upload an image and ask questions based on that image, like how many horses are there, what is this object doing in that image. So now the model has a thorough understanding of the image, not just a shallow recognition of the object. Okay, so there is a concept called as visual question answering that was also getting possible because of all these. So you might have already done that on ChatGPT and Gemini kind of models, where you would have uploaded some image and done some data analysis on it, let's say a plot or a figure, and then ask model to analyze that. Okay, so these are all the different use cases you can go through. We have been discussing some of these in the last session as well. Plus, we will be keep on discussing some of these in the coming sessions. So at a high level, customer service, document processing, content creation, code assistance. And then coming from the healthcare domain, again, clinical documentation, medical transcription kind of thing, literature research, patient communication can be automated, and personalized diagnostic assistance and everything. Okay, you can just check the cost, impact, the business values these models can have in these domains. Fine. And then typical use cases of GAN models. But just in one line, always remember LLM, large language models, will generate text. GAN models will generate images. That clarity has to be there, absolutely. Okay, and these are different families of model. Okay, families of models which might have a similar output, but they are architecturally different. So just like we all are human beings, but everyone has got a different surname. So fundamentally, we are all doing the same job. Okay, let's say, okay, I'm a data scientist, my friend is also a data scientist, but my family name ends with X, his family name ends with Y, and we both have got completely different upbringing we have a completely different culture, tradition, and everything. It's the same thing. Okay, two different families of models which have been trained completely differently from scratch because of the architecture difference, because of the data difference as well, because these models are coming from two different companies altogether. Again, you can also say that way. Okay, and so their understanding about these data is also quite different. So with experimentations, you will sooner or later find out which kind of model is better. But let me just give you in one line. Diffusion models are newer generation of image generation models. GAN models are older generation. GAN models came somewhere around 2014 and stayed up to 2018-19. Diffusion models started picking up 2019 onwards, and they are still there. Okay, so as of now, 90% of the internet is using diffusion models behind the scene to generate images. That's one line summary of the entire discussion. If anyone is asking what kind of image generation model is going behind the scenes, your 90% guess should be a diffusion model. Is that very simple? Okay. Had the same question been asked in 2018, I would have taken a very educated guess for a GAN model. It is as simple as that. Okay. Now, what goes in training, forward, reverse, let's not go into all that. If there is some technical person, they will be able to understand. But at a high level, at an architecture level, you really don't have to get into this. Okay. But yes, the main capability of a diffusion model is to generate very high quality, high definition images, which the GAN models used to initially struggle. And then we have different use cases. We can go through this.
Later, what we're going to do is we're going to do the exercise. That's where you will see, based on the business use cases, which model you're going to pick and why you're going to pick. Yes. So that's why the knowledge of these are important, but we'll explain and guide you so you don't have to worry about the actual learning. Deeper will come when we do the workshop on these basis points. Over to you, Prashant.
Yes, thank you. And here the decision framework is there. And I see in these decision frameworks, there are words like tokens, per image, everyone understands, but there are some additional words which are a bit new to many of you. So I'll discuss about the tokens in my next presentation. It's already there ready with me. Okay, once we start getting familiar about the models, what they mean, what they do, what they learn, how do they, some basic idea about the process will actually give you confidence rather than just seeing the models as a black box. Okay, so that visibility will change now. Okay, right now. Okay, that is the main takeaway of today's session. After the session, you will no longer see a LLM as a black box. Okay, that's what I can guarantee you. Okay, so let's go to the part 2. Okay, where we'll be diving deeper into some of these architectures which have been elemental to generate all the content. Okay, that's where I said architectures. Okay, now architecture doesn't mean we will go layer by layer. What is happening. So suppose this is a transformer architecture, I'll not go layer by layer, but a high level of understanding about the architecture is needed so that you get to decide which model is appropriate for what kind of a use case. That's why the architecture is very important. Okay, so that is the vision when I say the discussion of architecture is going to be needed. Okay, so at a very high level,
just before we move forward, one more thing. Those who are saying, oh, so actual when we go deeper layer by layer, we have a separate program which is where we cover. After this, we're going to go into deeper. Just wanted to reiterate, people should not feel, oh, this is we are running away. No, you will learn all this. Those are part of AI track. You will learn everything right from start to end, but we're going to do it in a strategic manner. So this class is more, as I said, for leaders, architects, and senior architects, enterprise architects who don't need to go deeper. If you are someone who wants to go deeper, there's something else coming. We look at how to build, manage, deploy, and look at some of these things actually deployment point of view. Over to you with that, Prashant.
Yeah, thank you. So these are the four main architectures we'll be discussing. One is a encoder model, decoder models, encoder decoder model, and there is a mixture of expert model. That is the fourth model I was talking about. Okay, so we'll be discussing these four models. What are the typical use cases in different industries? What are the limitations? And then we will also see what are the most common models. So for example, interview question. Tell me ChatGPT is an encoder model, decoder model, encoder decoder model, or a MOE model. These are very common questions.
Could have mixed answers. Good.
The answer is there in the forthcoming slide, so I'll not give you a spoiler alert right now here, but that is the fun here. That is the fun. So even without going into layer by layer, but at least at a high level, why is it a decoder only model? Or I mean, why don't we need the encoder component of it? So those kind of questions are very right questions that we can take up today. Okay. So yeah, that's the overall idea. Let's move on next. So transformer deep dive, why transformers matter. So this 2017 came up with this paper. Attention is all you need. And it's a small one. So prior to that 2017, when we wanted to generate text, the only way was to have RNN LSTM models. RNN is recurrent neural networks. So what is the main takeaway from this discussion, from this title? Okay. So now if you see deep learning, there are two types of networks. Okay. I'll just write down something and let's understand it this way. Okay.
Just again, guys, what we are covering these models, models, RNN, LSTM, there is a separate training we cover. So don't worry about if you're thinking, oh, we are not going deeper here. So there's a separate training in that we cover and go deeper, because I don't want to go. There's a deep learning. I think is if Said is here, we'll tell you if you want to know more about where are we going to cover this. Everything that we are talking here is covered somewhere or other, but because otherwise we'll go too deeper into it, will not make sense to a lot of guys. But that's there where we cover all these things. Over to you, Prashant. Let's continue from here. Yeah?
Perfect. So in deep learning, most broadly, anyone will teach you there are two different types of networks. Okay. One is convolutional neural networks, where we train on images for classification. Typically, this is for classification. Let's say classification means whether this is a cat image or a dog image. Is this image belonging to Prashant or Shah Rukh Khan? So just like classify different images based on the objects. So for that, if you want to train a deep learning network, you will be using a convolutional neural network, what we call it as in short, CNN. And then there are multiple variations of CNN. CNN is a very, very popular network. Hundreds of variations are there. RCNN, that is region-based CNN, fast RCNN, faster RCNN, mask RCNN, YOLO, single shot detectors, and number of variations of CNN models are there. But then people thought, okay, I need to have a deep learning architecture where I can train on text data. The problem with the text data is there is a sequence of words. See, in images, there is a placement of pixels. Okay, but if I say the cat sat on the mat, and the moment I jumble any of these two words, okay, the entire meaning and context of this entire statement is gone. It becomes an absurd statement. So sequence and placement of the word is very, very important. So people thought, okay, I cannot use a CNN in this case. Can I design a special network which will learn the sequence of the words or sequence of whatever input I am giving? Now, sequence of input could also mean time series data, because that is also a sequence learning. Okay, perfect. So then they came up with the idea of recurrent neural networks, which were good for sequence learning. RNN had some, inherent limitations. So they refined RNN into LSTM models, long short-term memory models. So they said, okay, we will train a deep neural network to not only capture the meaning and context of the words in a sequence, but also have some memory so that the model remembers what it has been given earlier. Okay, so what does that mean? So if I give you an input context like I was born and brought up in Germany, and then at the age of 21, I came back to India where I worked in so and so company and some other information. Hence, I can speak fluent. Tell me which language. If you paid attention, attention is all you need.
Yes, I can see there are comments
I
coming. One
was
second.
born and brought up in Germany was my very first statement, and the age of 21. So first 20 years, if anyone stays in Germany, they would be fluent in German at least, right? So see,
Am I saying
that information came some 10 statements before. So how does a model remember that much knowledge and context? And that is where the LSTMs became very popular. Long short-term memory models. So M is for memory. So long short-term memory. Okay, fine. So coming back, that's what this slide was all about. That people were satisfied to some extent, but it was still not able to generate. It was able to understand the context and the meaning, but generative capabilities were still very limited, and they used to forget earlier context by the time they are reaching the end. So to some extent they were able to remember, but not a context which was, let's say, hundreds of words long, maybe few words long. Some memory used to be there. Okay, so context loss was one of the biggest problems. So they can only handle short amount of text, small captions and so on, but any enterprise application was very much limited because of the length of the total text that it could generate, okay, or even understand, comprehend. Fine. And then the transformer model came, okay, which proposed the idea of attention mechanism. Okay, so what do you mean by attention mechanism? There is a word called as attention. Okay, so what is an attention? Okay, so let's say let me give a statement, maybe something like the cat sat on the mat. It is fluffy. Now you tell me, what is fluffy? Is the mat or is the cat?
Matt?
So this is a bit tricky, but there could be scenarios where the information will be present. So when you focus, when you try to, that's what exactly the transformer models are all about. Okay, so they will give attention to specific words while establishing the relationship with other words. So which words are strongly associated, which words derive meaning from other words, which words modify other words. If I say the white rabbit, so the white rabbit, rabbit is being modified by the other two previous words, which is white and the. We have the adjective and then we have the determiner. So that's how the models learn to understand a part of speech. That's how the model learns to understand the named entities. There is a use case called as named entity recognition. Donald Trump is the president of United States of America. Now Donald could be Donald Duck and Trump could be Trump Towers also. How does the model know that Donald Trump is the name of a person? Okay, how does the model know that Google is the name of an organization? Okay, United States of America is the name of a geopolitical entity. Dollar is the name of a currency bill. Okay, so these are called as named entities. So how do you teach model these kind of concepts? That is all coming because of the attention mechanism. Okay, so unless and until the model learns these parts of speech, dependency, grammar, this is the subject, this is the object. So cat sat on the mat, so cat is my subject, mat is my object, sitting is the verb which is being performed on that object. So this kind of structure cannot be taught line by line. The model has to learn on its own inherently from billions of documents. And by how does it learn? By paying attention to these words and their relationships. Okay, so I'll not get into all the details, but that is the whole core idea. So every word attends to every other word simultaneously, and the model learns which words are most relevant to understand each other words, and this can really capture long range dependencies, even which are thousands of words apart. Okay, and then parallel processing will that's like an implementation level detail. Okay, these RNNs used to take sequential data, but the main reason transformer models were able to train very fast compared to RNN models or LSTM models, even with the same amount of data, is the parallel processing capabilities. Okay, fine. You can just check out the remaining things. Before I get into,
Bishop, do you want to take a question, or we are good for now, or you want to take questions at logical point? I'm fine with either of them. If there is any question, otherwise we can take once we have explained.
Questions once I am done with.
Perfect. Yeah. No.
Okay. So I'll just
absolutely fine.
Yeah. Okay. So let me just draw this here. So this transformers, as I said, okay, there are encoder or encoder only. There are decoder only. Okay. And then there are encoder plus decoder. And then we have the latest ones coming as mixture of experts. Okay. So let's understand the meaning of each of them, although it is all there in the slides one by one, but at a high level, I'll try to give you a sound understanding of this. Okay. So encoder means you are representing an information in a format which is legible to a machine. That process is called as encoding. You convert that text, let's say whatever that text is, the cat sat on the mat. How does the machine know what is the meaning of this statement? What is cat, what is mat, and everything else? Okay. So the same statement, the cat sat on the mat. How do I teach a machine what this statement is all about? What is the subject? What is the object? What is the part of speech for each and every word? What is the meaning? What is the correct context of each word? And everything, right? So that is the job of the encoder. So encoder teaches the machine the interpretation of each word, the context of each word, the meaning of each word, and the meaning of the entire sentence when they come in a proper sequence. And that encoded representation is called as embedding. Okay. So when you pass a text to an encoder model, the output will be embeddings. So what are embeddings and where is it used? Let me repeat. So whenever you give a piece of text to an encoder model, whenever you give this text, so input was this text, this is your input text, okay? Whenever you give this input text to an encoder model, the output of that will be embeddings. Embeddings will contain all the information present in that text in a numerical representation. What is the numerical representation of this text? Could be some numbers 0.15, 0.12, 0.813, minus 9119, and so on. So these bunch of numbers, which we also call as vectors, okay, this bunch of numbers are technically called as embeddings. And to a machine, see, English is not a language which your machine understands. The only language your machine understands is the language of numbers. Let's be brutally honest and straight to the point. Your machine does not understand anything except numbers. If you want to teach your machine any language, that word, that sentence, that entire book has to be converted into a bunch of numbers. And that's exactly what we call as the embeddings. Okay, we'll also talk about embedding models today. Okay, so the process of converting is called as encoding. And who does that? Take any encoder model that will be able to do that. So the job of the encoder model is to represent the text into a numerical vector form. Okay, that is your text representation models. Text representation plus learning or context learning. That is all done by your encoder model. Let me know if you have any question here. Okay, is that very clear? The job of the encoder model is to make any text legible to a machine. So machine will be able to understand the meaning of any text after it has been processed by an encoder network. It's a neural network. What is encoder? It's a neural network. I'm not going into the architecture of that neural network, but when I say encoder, it's a neural network. So the input is very clear. It's a text. The output will usually be the embeddings. And these embeddings will capture all the meaning and context of all the text that you have given. Right? That
makes sense, Prasad. Makes sense, Prasad. And any questions? I think there's no question for now. Once we understand this, once we do assignment, things will become much more like people might have more questions. They'll become much more clear. But good job. Okay, yeah, makes sense so far to me. Okay. And yeah.
So now, if I want to add one more piece of information into this, let's say, okay, we have understood that the output of this is going to be embeddings, but how are they trained? If you're a bit more curious to understand, see, this is the main takeaway from all of this. Rest all the slides are information, okay? But the main understanding which I'm, explaining, this is not there in the slides. So for that reason, you have to listen to me. Okay, so, and that is also one good reason to attend my sessions. If you're missing, you'll get only 70 to 80% of the knowledge. Okay, I purposefully skip some of the things in the slides. Okay, which is mostly the cream.
Yeah.
Okay, so coming back, if you're slightly curious that how will I be able to train an encoder model? Okay, answer is very simple. Okay, answer is very simple. You need data, of course. So what is your data? Think about your entire internet of data. What is your entire internet of data? I can just write it down. You can say entire Wikipedia is there, entire Stack Overflow is there. Okay, Stack Overflow. You have gigawords, Common Crawl. Okay, Reddit. Okay, and all the websites, everything. Okay, this is entire internet of data that you have. You process it, make it neat and clean, okay, and then feed it to this neural network. But when you are training, there has to be an objective. You just can't do a training for, the model would be lost. What will I do after the training? You have to define an objective for the model or for the neural network, okay, so that the neural network knows that I am getting trained better, I'm getting better or not. So how does the neural network know that I'm getting trained? It will track that objective. Let's say you want to participate in Olympic 100-meter race. Your objective is to get within 10 seconds to qualify the Olympic finals. So your target is 10 seconds at least, okay, or at max. Okay, so now when you train for 1 year, 2 years, 10 years, your objective is to cross that 100-meter race in 10 seconds. Okay, so it's 12. Then after another year, it is 11 seconds. After another year of training, it is 10.5 seconds. So you're getting better and better. After every year passing by, you're getting better and better. Okay, that's how you get to know that I'm getting better, because my target is that 10 seconds. Okay, so same thing here. If I'm training a model, I need to set the target beforehand. I need to tell the model that, okay, boss, this is what you have to do. Fair enough? Okay. So now, what is the kind of training which is done for an encoder model? Okay. So there is a concept called as causal modeling. Okay. I'll just make it very simple. So you have the data, and then the task here is, okay, I'm just erasing this part. just to add additional training information now. Okay. And if you are missing out on anything, please go through the recording and add it to your notes. Okay. So now my statement is this. I have hidden this word. This is the masked word. Okay. So the objective here is, the training objective is to predict the masked word. Is that simple? This is called as masked language modeling. Okay, MLM in short. Okay. And if I have all the billions of information, by masking each word one by one, I have created a stream of self-supervised training objective, because the objective is very clear. Every time in every iteration, I'm going to mask one of the word. Mask means hiding one of the words, and the model is supposed to predict what word would be fitting here. Based on all the internet data that it has seen, it will predict, listen to me carefully, it will predict the probability of all the English words. So let's say in English we have 400,000 vocabulary words. So it will try to predict the probability of all the words which are probable at that position. So it could be cat, it could be dog, it could be table, it could be sky, it could be potato. Of course, now you know the probability of potato is 0.0001, probability of cat might be 0.01, probability of dog might be 0.001, table could be again very, very small. So I'm just writing down some numbers. Sky is 0.00089 thing. And so the highest probability comes out to be cat here. So the word which has got the highest probability will be the predicted word here. And that's how the model learns. And if it is not giving cat as the highest probability, then I will penalize the model and say, boss, you are not learning, because you should have paid more attention during learning phase, where I had actually told you that the cat sat on the mat. Okay. Okay. This is the word sat. Okay. So you had seen that data several times. And why are you not able to recall it then? If you have seen that word several times in your training set, you should be able to recall. So automatically you should have assigned a higher probability for that same word sat. Is that making sense? Any other nonsense words which may not make sense will have much, much lower probability to be fitted here. And that's how the model learns on its own. And then in the next iteration, I will say, okay, the cat sat, and now I'll hide this next word. And tell me now, start predicting what would be the next word. A, and, they, he, she, you, me, every other English word. Okay, give me the probabilities of all the 400,000 vocabulary words, and you should be able to mark the probability of the word on highest. Otherwise, keep rewiring your neural network. So the neural network keeps rewiring until the probability of the word on is the highest. Okay, in the next iteration, it will predict the as the highest probable word, and so on. So that's how the training goes. So that's why we call it as self-supervised. You didn't have to, prepare a annotated data set, because the target was one of the words which was hidden right in the same statement. Okay, so that's why it is self-supervised data set. Okay, we'll not get into too much details, but just to remember, okay, what is the training objective? The masked language modeling for the encoder models. What does the encoder model want to learn? They want to learn the text representations and the context of every single word, every single text that you provide to them. And what is the output of the encoders? Typically those embeddings, numerical vectors, okay, which encode all these meaning and context. Okay, and how did they learn? They learned by using this as the training objective. That's what I just mentioned. Masked language modeling, and very briefly I have explained that process without getting into too many technical details. Okay, now with that I'll move on to the next one, which is the decoder only models. Okay, but let me see if there are questions. There is one question here. So encoder interprets natural language text to machine language. Yes, to some extent, your statement is very correct, and it represents them in the format which the machines learns, understands. And that is your embeddings. And we'll be using those embeddings later. Okay. Later, but where? Okay. So that brings us to the discussion on decoders. Okay. So I could have given you the names of some of the encoder models before I just winded up that discussion. So most popular encoder models, if I just give you some of the names before winding up this, is BERT. Most popular. This was proposed by Google somewhere in 2018, Google DeepMind Group. Bidirectional embedding representations or encoder representations from transformers. Bidirectional encoder representation from transformer. Why is it bidirectional? Because once I'm going to feed my data in the forward direction, and in the next iteration I will also feed it backwards. So the model should be able to learn both ways. Okay, it has seen the same statement forward manner as well as the backward manner. This context doesn't change however you feed it. See, the cat sat on the mat will always remain the cat sat on the mat, whether you feed it this way or that way. So models should be able to, be so robust, and that's why this is bidirectional. Okay, very interesting, So BERT, and BERT was instantly a hit to an extent that people started chanting BERT everywhere, and they started creating several variations of that BERT. Okay, so BERT was humongous. BERT came in 3 variants: small, medium, large, just like your t-shirts. Okay, small, medium, large. Okay, so small had I think 12 encoder blocks. This is 18 encoder blocks, and this is 24 encoder blocks. Okay, and this was humongous. So people thought, okay, is it possible that I distill that knowledge what BERT model has into a smaller model? While distilling, what will I do? I have got 24 blocks. I'll remove some of the layers which may not be very important. And if I'm able to retain the same 95-96% performance in a much, much smaller model, let's say 1/100th of its size, why not? I mean, that's a huge advantage to business. Okay, so BERT became DistillBERT. This was done by another company, DistillBERT. So BERT became DistillBERT when we distilled this model. Okay, people were still not satisfied. Okay, can I even reduce it further to make it usable by a common man? Because these BERT models were trained by Google. Google is not a common man. Okay, we want a version which is usable by Prashant and Atul. Okay, so what we will do is I'll make it Robert. So BERT became Robert. Robert is robustly optimized. So they started further optimizing the BERT model to make it smaller and even more efficient, faster. Okay, so Robert is now giving you almost the same performance as a normal vanilla BERT, 97-98%, with 1 millionth the number of parameters. Okay, so you have seen a huge reduction in the number of parameters, and the performance is almost the same. Robert, and then came Albert and many more. So we'll not get you all the details, but the moment you search for BERT model variants, you'll see at least 50 other variants. Okay, so DistillBERT, Robert. So anything which ever ends with BERT, instantly it should click in your head. This is an encoder only model. Yes or no? BERT is an encoder model. All variants of BERT are encoder models. Second point. Okay. And all these encoder models will be able to generate embeddings. Fourth point, those embeddings can be taught. Okay, those embeddings can be used to let's say you have a BERT model. Why was it again so famous? All the variants of BERT. Why are they so famous? You might be thinking, okay, I have the embeddings, but is that all? Okay, I can fine tune these embeddings and train a classification model. So fine tuning. So what I'm saying is fine tune for classification task. So many other tasks, but these are one of the most common tasks. So sentiment analysis. Why not? So now I have a model, a large language model. This is literally a large language model which has been fine tuned to only do sentiment analysis. So if someone is asking, Prashant, what model will you take for a sentiment analysis? You can use ChatGPT, no doubt, but that is an overkill. Okay, technically you should not be using ChatGPT for that. Technically, if I strictly, as a LLM professor, if I say your answer is wrong, you should be using any of the encoder models, fine tune them for a classification task. What is fine tuning? That we'll discuss later in the subsequent sections. But point here I'm trying to make is, since the model have learned all the meanings, all the context, different contexts in which every single word in this entire dictionary can be used, so they also understand the meaning, context, and sentiment and sarcasm of these words as well. You see? So if the bot understands the meaning, context, sentiment, and sarcasm of every word, why can't I use it for a sentiment analysis task? That's a very natural outcome. Very natural outcome. So indeed, yes, people are doing that. So if you go to Hugging Face, I'll show you at least 1 million models are there which have been fine-tuned to do the sentiment analysis on different domains. Okay, and they are all starting with BERT. Okay, so just give me a second. I'll go to Hugging Face, where you will find all these different variations of BERT. Let me just clear my screen. So Hugging Face is a repository of models. Okay, open source models. That is the first word. Repository of open source model. You can literally download and access these open source models in your local machine. And you can see it's 2.29 million models are already there, which have been categorized in 48 different tasks. So on the left side, you can see these tasks. I'll just click on the task here and take which task. Sentiment analysis is a text classification task. That's a text classification. So can I go to natural language processing and text classification? So the moment I click on this text classification, instantly back to back everything that you see is this is a FinBERT. A FinBERT, a BERT model which has been trained on a finance data. Roberta, just now I told you, a BERT model, robustly optimized BERT model which has been fine-tuned on Twitter data for sentiment analysis. Okay, multilingual sentiment analysis. Again, this is BERT based. So most of them, 99% of them are BERT based. Okay, you can see Roberta based sentiment, and then Roberta based, all these Hail-BERT, Indo-BERT, Roberta, Distil-BERT, base, uncased. Now, uncased means in the training corpus, we had all these words in small case. That is uncased. If you have a mix of small case and uppercase, that will be called as a cased model. SST2, this is one of the benchmark data set. SST2 is Stanford Sentiment Tree Bank version number 2. Stanford Sentiment Tree Bank. That's the name of the data set. It's the name of the data set on which this model Distil-BERT was fine-tuned. So BERT was first distilled. You got Distil-BERT, and then this Distil-BERT was fine-tuned. That's exactly what I was talking. You take a BERT model or any variant of the BERT model and you fine-tune for a specific task. What is the task that I chose here? I chose to do a sentiment analysis task, and this is the result. This is the result, you see, and everyone is doing this. Everyone is doing this. This is one of your best, projects. If you want, you can showcase in your resume. But again, this is a researcher level project, not a architect level of project or a developer level project. Let me warn you. So unless your profile is a AI researcher, don't go for fine tuning. So if you are still thinking about, yeah, Prashant is talking about fine tuning, should I be bothered? Answer is no. Don't directly jump into FOMO things. Okay, so fine tuning is only for those folks who are looking for a AI researcher roles, not for developers or architects. At a high level, what fine tuning is, that anyway we will know, but you don't have to jump into a fine tuning project how this model was created. Okay, But yes, this is how you will be able to read any new model name now. Any new model name. See, most of them are doing sentiment and plagiarism detection, toxic comment, and they are all BERT based. So that is the significance of the BERT model now. That is the significance of encoder model that we have learned now. Simple.
Yeah, just to add on that point, we are going to do implementation of all that either in AWS, Azure, or your agentic AI. All those things, actual implementation will come, so you don't need to worry about stress. In fact, we are going to do some fine tuning as well. And a lot of guys were concerned about the lab, how we're going to do. We're going to cover on the respective program, so don't worry about it. Those actual implementation, this is where you go. Whatever you're learning here, actual implementation will come onto those points as well. So don't stress out. Once this is more concepts, theory, understanding, so that you can talk in that language. And then when you actually implement it, that these things, two things will marry up onto you. So any of you who want to do it early, just put in the group and say, I want to do this lab. We'll point you where that lab is. But please, I don't want to rush and run. I don't want to do, we can give you a lot of things, but I don't want to do, start running before you know how to walk, how to crawl. Otherwise, you'll fall and you will get stress yourself and everyone else. So the process will come. Earlier, I had a problem or challenge was I wanted to rush and run everything, learn as quickly as possible, but not everyone is inclined and aligned for that. Okay, but so again, including also those embeddings, where do you store them, how to store, how do you check, store, vector databases, all those things will be coming and you will learn and implement. Over to you, Prashant, with that. Okay.
Thank you. So now, given this as the context, so P of X, given this as the context, the cat sat on the. So this is the context which I'm giving to the model. Okay. So what is the decoder model trying to do now? Let's understand that. Okay. So decoder model is going to do the next token prediction. That is the objective. So in the previous case, what was the objective? Masked language modeling, MLM, for encoders. Okay. But for decoders, the training objective is next token prediction. What does that mean? So for a given context, this is the context. What should be the next token? Token for now, just imagine it's a part of a word or part of a word. Okay. So we'll see what exactly technically that token means in the next presentation. I have it ready. So, but for now, just imagine token is nothing but a word or a part of a word. So what should come next is what I want a model to predict. This word could be, again, could be mat, could be rug, could be sky, could be table, could be chair, could be, anything, book, and all the English 400,000 words. Okay. All for each of them, again, I'll get probabilities. For each of them, I'll again get probabilities. I want the model to learn in such a way that the probability of the mat is the highest amongst all these words probabilities. That's how I'm going to train it. If the probability of the word mat is not the highest, I'll penalize the model, and again I'll retrain, rewire, do something so that somehow the model predicts that mat should be the next word. Okay, so you keep on hitting the model or training the model until it becomes so proficient and confident that every time you ask the model, okay, the cat sat where, it should instantly say mat. Okay, without the second thought. So that is the next token prediction for a given context. That is what the model is predicting. So if you see in the previous case also, it was predicting probabilities. Here also it is predicting probabilities. So at the back end, your statistics, probability, mathematics, everything is still valid. Okay, without anyone noticing, but that's okay.
No,
there is one small.
Sorry, go ahead. Sorry to interrupt, Prashant. Carry on, please.
So there is this, very small connected concept here. I'll just finish with that and then we'll move ahead. Okay, and that is these models are also called as autoregressors. Slightly technically, but why are these autoregressive or autoregressors? Okay, answer is very simple. The moment it has predicted this is the word mat, fine. Then you might be also interested to know what after mat. So to know what after mat, you have to provide everything into the context. So whatever word it has predicted gets appended to the context every time. So the context length keeps increasing. Do you realize that is the meaning of auto regression? Okay, automatically whatever the model is predicting as the next word gets appended to the previous context for the very next word to be predicted again. So to predict this word, I need everything till here. So let's say it predicted maybe a full stop, okay, as this top token. Then what will be the next word? So then after full stop, normally in English, we'll have a white space. So, okay, it will predict there should be a white space. Okay, but to predict that it has to be a white space, it has to know everything from here to here once again. It has to see that full stop, then only it will predict a white space over here. So do you realize that every time that output is getting appended to the previous context, and that is why this becomes auto-regressive in nature. Okay, so let me summarize once last time. The decoder models are text generation models. If you have still not realized, this is the actual true text generation model. Okay, encoders are not used to generate text. Let me repeat it second time. Encoder models are not used to generate text. You will need a decoder model to generate text. And what it does not generate, okay, we'll not get into all the details, but if I just speak at a very high level, it doesn't directly generate text, it generates tokens actually. Tokens are IDs. Okay, let me make it simple. So decoders are text generation models, and they will generate text token by token. That's the reason I'm saying next token prediction. So one token by one token, what should come next, and then what should come next, what should come next. Don't think that this entire phrase will be predicted at one go. So one by one, each token. For now, token is a word or a part of a word. It could be even a punctuation. Okay. So bit by bit, the model is predicting based on the previous context that you have provided. So that makes it simple to say that decoder models are all your GPT models. That's your answer, which I asked 45 minutes ago. So all GPT models are decoder models. All your Claude models are decoder models. All your Gemini models are decoder models. All your Mistral models, all your Llama models, whichever model you use to generate text, poems, emails, content writing, digital, everything. Okay. So these are all decoder only models. Simple. So that is the typical use case of the decoder models. Yeah. So let me see if there are questions here.
There's one question Shrikant is saying, then how with the encoder only models we use or work if not generating the text?
So if you remember, I said the output of that is an embedding. So we are directly going to use the embeddings in a RAG system. That is the clear answer to your query. Okay. So embeddings are directly used. Indirectly, they are used many other places, but encoder models are directly used. The BERT models or any of these Hugging Face BERT models I mentioned. You can use any of these models for sentiment analysis. One example I have used. Now I've already given you. For part of speech recognition, named entity recognition, all you have to do is just take an encoder model, okay, and fine tune it. So that's the only catch here. So encoder models will generate embeddings, and then you'll have to do something called as fine tuning for a different task. So what task? Sentiment analysis, text classification, okay, text classification, topic modeling, or topic classification. Okay, let's say this news item is a sports news, political news, tech news, finance news. So how do you classify that text? So that is a normal text classification, topic, sentiment analysis, or just now, as I said, named entity recognition, okay, part of speech tagging. So all of these are different use cases. All you have to do is just slightly retrain the model based on the same understanding. So it has seen the entire internet of data, but you just have to polish it. And that polishing is not generic step. Polishing is based on specific objectives. Why, for what purpose you are doing that polishing? And that polishing is what I'm calling it as a fine tuning. You need to polish that model. That raw model will give you embedding. If you want to use it in the raw format, no problem. Your RAG system actually uses it in the raw format.
Brilliant work. Okay, guys, one more thing I will tell you is one more tip I'll give you. If someone you're worried or why someone guys are asking more advanced questions, if you're coming first time or if you're new to this, don't worry. These guys have been doing this. They've attended multiple sessions in the past. That's why they happen to ask questions, so many deep questions as well. If you're worried or if you're lost because this is just day 2 or some of you guys coming day 1, don't worry. You will go back to these when you revise couple of times, things will start making sense multiple times. That's why we have a limited retake over the next 1 year. You can come back again. That doesn't mean that you should not study. Go immediately after that, do a recap again, make notes, list down all the questions and ask in WhatsApp group. If we can answer, fine. Bring them in next week. We'll be covering as well. We'll take 1 or 2 more questions, Prashant, before we move on. Over to you, Prashant. Okay, if you want to continue with this, what you're saying.
Okay, there are no more questions.
I'll take you then in that question. So there was a question from BC was saying, or Bhumika was asking about. You mentioned about text, but then how about audio and video information? How they're embeddings done?
We'll see that. There are special models for audio embeddings and video embeddings. So there are also special models actually. Okay.
Okay. One more question I'll take.
It is a multimodal model. Yes.
Yeah, Jeet was saying, oh, there is already so much work done. Don't worry about Jeet. I used to be worried about, I'll tell you my story back in 2012 when I came in from Oracle. I was working a lot of Oracle Identity Access Management, Oracle Data DBA's part. And then I went into 11, 12. I was worried because everyone's job was cloud and I thought I'm late behind. I'm 5 years late. Everyone's 2007, 8, 9. I'm already 2-3 years behind. Trust me, I got so much work in cloud and multi-cloud since 2012 till 2018, 19, when I decided, oh, I'm going to go into more machine learning, these things. Till 2019, in fact, 2020, 21, a lot of work on multi-cloud, and still there's a lot of work going on. So we are just at a very early stage of this phase. So don't worry about, don't stress out. You're at the right stage, right time as well. Okay, with that, over to you, Prashant. We'll continue.
Okay, so basic question is then, if I have a text in English, and I want to do some translation. So someone in the chat asked about translation. So that was my next natural thing to discuss. So I have a text in English, which I want to translate in French. Okay. Which model to use? Option A, encoder. Option B, decoder. Option C, something else. So it cannot be only encoder because encoders cannot generate text. So that is the worst answer, I would say. I want this to be converted into French. So it has to generate French words, right? So you cannot use an encoder model for that. That's super clear. Can it be directly decoder model? See, decoder model technically can do that, but without having the right context, it cannot do that. So you need an encoder plus decoder model in such case. So all the translation jobs, summarization jobs, okay, these are all done by encoder plus decoder architecture. Because you need to train the model about the meaning and the context of the words. Otherwise, see, what will happen is there is a term called as transliteration. So transliteration means converting each word into French in the same English order. See, the French grammar does not follow the same ordering of the words as in English. So when you translate, okay, new bunch of words have to have a coherent meaning in French. It cannot be, transliteration. So let's say, my name is Sundarlal Chadha. Okay. I mean, for people who are coming from, Indian background, understood this joke here. It's literally a joke. Okay. So if I just do a transliteration, to mera naam beautiful red knicker, right? So Sundarlal Chadha will become beautiful red knicker because that's what the English transliteration would mean. So beautiful red knicker is not my name. My name is Sundarlal Chadha. So how does the model understand that Sundarlal Chadha is the name of a person? You cannot do a transliteration. That's the exact meaning of translation versus transliteration. So in translation, the meaning of the entire sentence is maintained. In transliteration, you are literally converting every word in a new language without paying attention to what it means in the larger context. So how is that possible? That is not possible without the help from an encoder model. So decoder will ultimately generate this. but encoder is needed to understand this. The nuances in the source language will be understood by the encoder, and the decoder will ultimately generate the text in the new language. So you need a encoder plus decoder architecture for translation jobs, transcription jobs, medical transcription, okay, even summarization. Okay, so these kind of activities or tasks are done by a encoder decoder model. Okay, now let's go back and let's see what all we have covered, and I'll go for a break and a quiz after that. By that time, I actually also brought up this diagram. So if you see, this is the complete transformer architecture. I actually didn't want to show this because again, it will lead to further.
Yeah, I'll go again in a project. It'll open a can of worms, and it's not a topic which you can cover in 5 minutes or 2 minutes or 3 minutes. It'll go deeper, but there's a training available. Sant, ask my team if you want to go any topic that you want to go. There's already plenty of trainings available inside. We'll point you to someone, either Prashant or someone else would have covered this. So we'll go deeper into. Again, I want to keep it high level. If you want to go any point in time deeper, just ask us. We can go very, very deep into each of these topics. Okay, over to you, Prashant. Again, back to you.
So yes, this is a quick recap. Now, I think we have already given all these classification tasks, sentiment analysis, categorization, detection, okay, extraction, named entity recognition. That's what also I was talking about, part of speech tagging. So all of these information extraction, data mining, these are all the activities which can be trained for a encoder model. Okay, these are all BERT-based models, you can see. And these are all the different variants I was talking about some time back. Roberta was created by Meta, because Meta will always come with their own variation of anything what Google does always. Okay, so Roberta created by Meta, DBERTA is there, FinBERT, SegBERT. Again, these are all fine-tuned for banking and investment analysis and trading applications. There are further applications coming from the health care domain. Okay, again, this is recognition, extraction, identification, classification. Look at the last words here. Okay, that tells you that mostly it is categorization, understanding the meaning, context, and that's the main takeaway. Okay, decoder models, these are all the GPT series models. Okay, and they are the ones. So here the predict the next word, that's the core idea. That was exactly very clearly I mentioned. Okay, you have to train this model to predict the next word based on the previous words. That's what exactly I mentioned, okay, in my discussion. And output will be generated text, but token by token. So what is a token? I have a detailed presentation on that. I will share that with you today as a homework for you to study, and that we will discuss in the very next lecture. Okay, I created this presentation today, just a couple of hours ago. Okay, this was not earlier planned, but I will give you this additional homework to study. This is pretty much detailed for people who are completely new to tokens and the concept of tokenization. This will give you a very thorough idea. And anyway, I'll discuss about the word tokens, tokenization in the next session. But for now, just understand that token means a word or a part of a word. Okay, so if I just go to this, so my name is Prashant. If I feed this to a LLM, it will break down into 7 tokens. And which are the 7 tokens? My is the first token, name is the second token, space is, there is a space here, okay, then space PR, and then ash, and then ant, and then this exclamation. These are the 7 tokens the model would be seeing and learning and predicting actually. So these are the spaces which are a part of that token. Remember that. And you can actually go to this OpenAI tokenizer, type down your names and see how many tokens are contained in your name. Okay. So this, let me just type it down here, and you can see in real time, it tells me that Prashant contains 3 tokens. So you can do this activity. Okay. Later, maybe I can just share this link. So Shahid has already shared that link. So we'll talk about all these, but just in one line again, coming back. So wherever you see this word token, understand that either it would be an entire word, just like these cases, this entire word, my name is, because these are dictionary words, but Prashant is not a dictionary word. So then how does an LLM make sense of that Prashant? So it will break it down into something which something which is more, I would say, easy to handle. Okay, so that was the logic. Fine. Yeah, the
Later,
use cases.
I was saying is when you do the lab, we are going to talk about tokens, how many tokens you have to restrict and all those things. So there's a prompt engineering labs you're going to do. So that time you will understand a little bit more in terms of also a pricing, costing, though the amount of tokens we're going to use is very, very minimal. But in actual implementation we're doing, how many tokens you use based on how many, what kind of a prompt, how deep you go, what kind of a questions users can ask, what kind of responses they can get. All those, there'll be cost implications of those, how many tokens it generate, how many tokens uses to read the data that you're inputting. All this is based on the costing will be involved. So again, when we do the labs, that's when you'll understand restricted by number of tokens that it can use and so on. But again, all these things will become and tie up everything when we're going to implement these some workshops. Over to you, Prashant.
Perfect. So this encoder decoder, again, as I said, some of the tasks like summarization or translation, where the encoder comprehends what the input is all about, and then the decoder will generate the output based on that understanding. And these are the distinct architectures. So these are the typical use cases. I have given a lot of such use cases both from the BFSI and the healthcare domain, but primarily these are all based on summarization or converting data from one format to the another format. Let's say you have a data in CSV format which you want to convert into JSON, okay, or translation English to some other languages and vice versa. So for all of these, you will need a encoder decoder architecture, and T5 is the architecture which was initially proposed by Google, and later on they just made different variations of that. So T5 is 5 T's are there: text, to, text, transfer, transformer. These are the 5 T's. Okay, you are transferring the learning from one text to another text. That is text to text, transfer, transformer, T5. And then came the Flang T5, which is a distilled version of that, and so on. So you might get the name Flang T5 also somewhere.
So I'll read out the question. Question was that your compliance team needs to extract keyword terms from 500 contacts. So this is a very good use case where you say these many contacts are there, and I want to respond very, very quickly. That reminds me, I was watching a tele this Suits, where he has to go through, I think, tons and tons of legal cases, and they have to respond and summarize all those within next day morning. So one second. So that is kind of a use cases. This is very, very common use cases. So which will be using? Over to you. There was a close tie between BERT and GPT-4.
Okay, so basically your compliance team needs to analyze 500 customer contracts to extract key terms. So you remember named entity recognition? I spelled out that several times in my discussion in the last half an hour. And so answer, I had spoken several times, that's a standard use case of a BERT model. Okay, so this is information extraction. You can say classification or NER kind of a use case, not generation. So definitely never I'll go with a GPT model kind of thing. I mean, yes. So BERT is 1,000 or even 100 times cheaper than a GPT model for this particular task. DALI is for images, and GANs don't extract information. They are image generation models. Clear? Next one. Okay. So this is on the architecture application. Again. So your marketing team needs 1,000 unique product images for a catalog. Which architecture would you choose?
We discussed this earlier, guys. Remember, we discussed about for images what you will be doing. Yeah. For images. Again, the keyword is about product images, unique product images.
Prashant, DALI is the name, of a model, you can say. Here, the question is more about the architecture, because the names that you see on your screen, they are the names of the architectures rather than just the names of the models. So, okay, so I would use a diffusion model, DALI or stable diffusion based. Yes. So these diffusion models currently produce the highest quality of images with the best control, I would say. GAN models can also work, but they are less stable. So remember this. And LLMs do not generate images. Large language models. So they are language models. They technically cannot generate images unless they are multimodal. Now GPT-4o is a multimodal. O1, O3, these are all multimodal, and all the later some of the like Gemini 3 itself is also multimodal. So many of these models which came post December 2024, they are all multimodal in nature. And that's why, OpenAI started calling them as omni model. Omni means which can do everything. So for O, that main logic behind O was omni, and which is multimodal, multimodality, let's say. But yeah, the question was more about the name of the architecture rather than just. So GAN can be done, but they are less stable. But now you are not talking about a hobby project. Okay, you are doing it for some serious business. And again, another hint was GAN is older generation. I mentioned it very clearly that now almost 90% of the image generation is taken over by diffusion models. So if you want to do it today, your go-to choice would be a diffusion model. I hope that is very clear now. So another very straightforward true-false kind of a question here. Transformers AI models processed text sequentially. Before transformers, AI models processed text sequentially. Remember the RNN LSTMs I talked about. So this should be very simple. Yeah. So yes, before the transformer models, these RNNs and LSTMs were sequential, right? I already talked about that. And that causes memory limitations, slow processing, and so on. And transformers itself, while doing this self-attention, that processes all the words in parallel. So the cat sat on the mat, all the 7 words are being processed in parallel, not in the same sequence. RNN would process each word in a sequence. Transformers process all of those 7 words parallelly. So which task is BERT, which is an encoder only model, best suited for? So now these are the business use cases. So I already conveyed the technical part of it. Now comes the business part of it. Okay. So it will be, excelling at classification and understanding. It's an encoder model. So excelling at, classification and understanding. It cannot generate long form of content. So basically you're generating a 5-page financial report from data tables. That is out of question. That's the typical use case of a maybe a decoder or an encoder-decoder model. And the other option was creating personalized email responses to customer inquiries. That is again a typical decoder kind of a model use case. Or effectively translate. So translation, English regulatory documents into Spanish. So that is a job of the encoder-decoder 100. So good job. So now at least that thought process is working, and be ready for another question on strength and weaknesses of GPT model here. Okay, perfect. So GPT models can generate plausible but factually incorrect information, what we typically know as hallucinations. So grammar is usually good, but accuracy requires validation. So fantastic job, everyone who has gone for the last option. So this one is again non-graded, more about the hallucination experience. kind of a poll, you can say. Have you or your team experienced AI hallucinations, which could be very plausible but incorrect outputs? Have you been a victim of that?
Okay, in fact, while everyone is answering that, again, yesterday only I was reviewing one of the lab we have done in AWS AIML on hallucination, where we've given some prompts and it gave a very, not, I think it's more hallucination, it's more biasness, which is the ChatGPT or like the model was very biased on a typical industry with a typical background. So I wouldn't call hallucination, I think it's more biasness, but closely related. We'll do some of these examples and implementation of those things as you come across. Okay, over to you, Prashant.
Yeah. So yes, occasionally we have validation processes. Okay. Yes, frequently that's a major concern. So the top two results, I'm pretty happy that the organizations are really taking that seriously. Okay. And others are still aware, at least that's pretty good. And sooner or later, measures would be taken. That's perfectly fine. Okay. Next quiz. That is on, again. So you have your team that needs to summarize 1,000 customer support tickets daily. Each contains, let's say, 500 words into a 50 word. So 500 words down to 50 words. The most efficient approach would be what?
This is something we should start using and leveraging. I don't know, we have around 10,000 tickets in last probably 3-4 months. So I have to start using that. Okay.
So T5, I talked about that, as fine-tune a T5 encoder decoder. So summarization task, I think I had been very clear that for translation, summarization jobs, you would need an encoder decoder architecture. Okay, encoder will understand the original document and the decoder will summarize it based on the understanding it got from the encoder part, right? So T5 is optimized for text-to-text transformation, and it's more efficient than GPT-4 for structured tasks like this. If you have a very consistent structure of the inputs and outputs, then I would always go with a fine-tuned T5 model rather than doing overkill by using GPT-4 model. Both cannot generate any summaries, please. Okay, and diffusion is for images anyway, so that is out of question.
It has taken longer time for me to read the question.
Okay, no worries. So now there was one slide which I wanted to discuss on mixture of experts. I'll take 2 more minutes. I hope that is fine. Okay, before moving into that last question. Okay. So, and that is the concept of mixture of experts, and that finishes all the architecture discussion. We have already discussed encoder, decoder. This is the last remaining framework. Okay. I'll just take 2 minutes. Now, a very simple idea here is, if you would have heard about this name DeepSeek. Everyone, is there anyone in the session who has never heard about the name DeepSeek? DeepSeek model from a Chinese company. I think everyone, right? So what DeepSeek did was pretty intelligent. It's not that they were doing it for the first time, but they open sourced it for the first time. Okay, that was the main reason DeepSeek got instant fame. Okay, it's a 670 billion parameter model. 670 billion parameters, humongous model. Okay, so just imagine to host and run a 1 billion parameter model, you will need 8 GB of GPU RAM. So 670 billion parameter model. Now that multiplied by 8. Okay, that is the kind of infrastructure needed. Okay, but that was not the main point I am talking here. Think about your brain. Okay, your brain also has neurons, billions of neurons. When you are doing some focused task, let's say you are looking at some image and trying to recognize, is that Shah Rukh Khan or Salman Khan or Tom Cruise or Angelina? You're just trying to recognize the person from that photograph. all the neurons which are related to the visual cortex, they are the one which will be fired. You might be getting some noise from the background. You don't care because your entire brain is processing that visual information. Someone is touching you, maybe pushing you. You are also getting nice smell of the dinner coming. So your brain is simply ignoring all the other informations, and only those neurons which is needed to process, because you are entirely focused on one task. Same goes here. So DeepSeek, what they did is they created a mixture of 16 experts, 16, okay? By recognizing that most of the users will either generate emails or generate some content or do summarization or do some classification or do some sentiment analysis or do something. So they found out that these are the 17, 18 tasks which are most frequently done by people using these LLMs. So they created expert model for each of these tasks. And then they had a meta model, which is like an orchestrator. Now, whenever a user says, okay, summarize this, then only a small fraction of the 670 billion parameters are activated. And that number is only 37. Only 37 billion parameter small expert model is actually active and responding to the user query. So I've created a mixture, means like a army, you can say. I have a team of 17 experts. Each has been fine-tuned for a very specific task. Now, the moment user query comes in, I will route it to the right expert, and that expert, which is only 37 billion, it will be instantly fast. Compare it to GPT-4, which is 3 trillion parameter model. My 37 billion parameter model would be so instant. So it takes much less time in inferencing. TTFT is much small. TTFT is time to first token, one of the strongest indicators of your latency. How much time does it take for the first token to arrive? That is called as TTFT, time to first token. That is the metric used to judge the latency. Okay, so I don't want my user to keep waiting for 2 minutes because my request has gone to a humongous model which is taking ages to think and then respond. Okay, so if your task is simple, pretty straightforward, why can't it be done by a simpler model? So that's what the DeepSeek did. So it created a mixture of experts. So that is the whole idea here. Okay, you create smaller model, each fine-tuned for smaller specific task, and then that user query comes in. It will be routed to that specific fragment or part of the entire bigger architecture, and that will generate the response instead of all the parameters of all the models computing together. That's the whole idea, you can see. So expert network, specialized submodels, for example, 8 experts, each 7 billion parameters. That's a small example I have given. And to give the true numbers, 670 billion parameter DeepSeek V3 model, out of which only 37 billion parameters are active at any point of time. They're active at any point of time. So all of them are not doing number crunching or computing to serve the user query. Okay, so that is why your organization doesn't send every question to the CEO. You have different department heads with specialized expertise. Okay, financial, legal, operations, and executive assistant, who is the router, will direct each question to the appropriate experts. Fantastic analogy, you can think, right? So more efficient than one person being expert in everything. Right? So that is the business applications. And some examples are there. You can see GPT-4 is rumored to be more than 1 trillion. They are not even disclosing their architecture, but there are other open source models who have disclosed their architecture. For example, Mistral 8x7b model, it's a 56 billion parameter model, and only active is 13 billion at any point of time. And you can see that's the reason it is pretty cheaper. Why cheaper? Because it is computing less. So it needs less memory to compute, faster time, and so GPU compute friendly. So it will be cheaper. So if your job is pretty straightforward, why do you every time have to go with a more generic model like GPT-4? They are capable of doing everything. So if your task is complex, then maybe GPT-4 is good. But if your task is very well defined, straightforward, you don't need a generic model like GPT-4. That's the whole idea. So I think we'll wind up here pretty much.
Well, that was module 1 of my AI for Leaders program. Now, below this in the description or the comment section, I'm going to give you some quizzes. So go through the video maybe twice, make notes, and then go and see how much you can answer those quizzes and how much you score. That is a good way to understand whatever you picked up or learned from this video, how much you do. If you have any questions, anything that is not clear, or if you want us to go deeper, leave a comment as well. And the more likes, shares, or comments I see, the more I'll release the future videos as well. We have a lot to cover in this program. If you need our help or use any of the 3-step framework which I mentioned, then please reach out to us. With that, this is Atul. I'm going to cover another video. So keep an eye on this channel, and I look forward to see you in another video. Till then, take care and bye for now.